Hello, good evening everyone. So any questions from the previous class if you'd like to ask? Sorry, which? PSLV has as many as in past 6 variants. The question is asking is that PSLV has many variants. PSLV in past has as many as 6 variants. जो capability हमने discuss किया था, that is the variant which has the maximum capability. I think it is XL perhaps. But apart from that, there are many other variants depending upon how much fuel they are carrying. ये detail हमको जानने की ज़रूरत नहीं है. That PSLV के जो further variants हैं, उनमें क्या differences हैं, इसमें बिल्कुल हमको जानने की ज़रूरत नहीं है. Sorry, cryogenic में? What is CET exactly? I'm not very sure. क्या है CET क्या है? On which page it is mentioned? So even within cryogenic there may be some variants, but I am not very sure if this is required for examination. So even within cryogenic fuel there can be certain variants, but as far as I think about UPSC civil services examination, they will not go into such technicalities of things. Even a basic level of understanding about cryogenic should be more than enough to answer questions in prelims or mains examination for that matter. You had a question. SpadeX has nothing to do with, frankly, debris per se. इसकी बात कर रहे हो ना? To provide in-orbit servicing, ISRO is developing a space docking experiment called SpadeX. So this is basically a mechanism that, let's say for example, we have to go to International Space Station. International Space Station पे जो astronauts जाएंगे, they have to connect whatever capsule is carrying them. That capsule has to connect itself to that particular space station. So that mechanism is called docking mechanism. That how we have to deliver something into space to another infrastructure is called docking. Now ISRO is actually planning to develop a space station of its own in future, and this is an experiment in that regard. So as such, it does not have a direct focus on debris, but the goal here will be that even such type of mechanism, such type of docking mechanism should not lead to any type of debris creation. In orbit servicing, as the name suggests, that something is already into orbit and you are delivering something to that. You have to match the speed of that particular object and you have to dock, you have to deliver something to that. Jaise, very good example, again I will go back to a capsule carrying astronaut, and it is attaching itself to International Space Station. Now International Space Station in itself is moving very fast. It is revolving around Earth very fast. So you have to match that with station and dock itself. Can you go to tell me which page basically? The type of fuel which has been used in different type of rockets. Liquid hydrogen oxygen, that is clear, but what is the other word you are using? I'm not very sure if I understand the difference between these two type of fuel. I frankly do not know. But I also do not think this is important, right? I also do not think that this difference between fuel into different type of rocket इतना detail में जानने की ज़रूरत है हमको. Sorry? Moon system. We can say that because in distant retrograde orbit we were trying to attain stability around moon with the help of Earth's gravitational force also. It is a three-body problem, but it does not have to be necessarily at the Lagrange point, because if I'm talking about Lagrange point L2 of Earth Moon system, then the object is revolving or at L2 point but revolving around Earth basically, as moon revolves around Earth, revolving around Earth. So not necessarily, but nonetheless it is important because we are also accounting for Earth's gravitational force here. This orbital stability is also because of Earth's gravitational force. So it does not have to be exactly in the Lagrange point of Earth Moon system. Any other question? So in the last class we were talking about यहाँ तक हमने डिस्कस किया था स्पेस सस्टेनेबिलिटी की. Space tourism is a small topic. Again, I consider this topic to be more important for men's examination, but nonetheless there are few things which you should know. Lot of companies have shown their interest that a new, entirely new economic sector which we are calling space tourism. An entirely new sector, nothing was happening here, but an entirely new emergent sector that people, normal people, not astronauts, normal people who have of course a lot of money, they can go and stay their time into space. The definition of space, this is a definition, space starts at an altitude of 100 km above the surface of Earth, but frankly speaking this does not have any technical basis. This is just an approximation that we have included, that Earth के ऊपर आप 100 km ऊपर चले जाओ, we call it Kármán line, and above Kármán line you are into space. But this does not have lot of technical aspect into it. The main focus of Kármán line, the main focus of space will be that where you can maintain an orbit around Earth, where you can feel weightlessness, where you are above atmosphere, the atmospheric drag is not on you, so that in a way you are able to maintain some sort of orbit around Earth. Now here is the thing, atmospheric drag depends upon where you exactly you are on the Earth. On equator, on pole, the atmospheric drag hoga, that will not be same at 100 km. It will be different in these both places. So that is why this 100 km definition, it does not have lot of technical reason behind it, but just all of us are on the same page. There is a concept called Kármán line, that let's call it that 100 km above Earth's surface and you are into space. So 3 companies have shown interest into space tourism, and ISRO is also trying to become a player. So 3 companies: Blue Origin, which is a company owned by Jeff Bezos, former CEO of Amazon; Virgin Galactic, a company CEO Richard Branson; and Elon Musk की जो SpaceX company. All 3 of them have demonstrated that they have capability to carry human beings into space. However, जो first 2 have Blue Origin and Virgin Galactic, they have actually not demonstrated this capability of a complete orbit around Earth. So 2 type of space tourism can occur: a suborbital tourism or orbital tourism. Suborbital tourism simply means that you go around 80, 90, even 100 km, do not complete an orbit, but for some time you are going to feel weightlessness into space and then you return back towards Earth. While orbital flight simply means that now you will go up to height of 400, 500 km, यहाँ पे atmospheric drag is almost zero and you can maintain a stable orbit perhaps for a day, more than a day, and then you can come back on Earth. So when I talk about space tourism, it means 2 things. It can be either suborbital flight. Suborbital simply means that you are not completing one orbit, or it can be an orbital flight that you are into space after completing at least one stable orbit, maybe more than one orbit, staying into space for some time and then coming back. So the Virgin Galactic or Blue Origin का जो flight था, which was actually made by Richard Branson and Jeff Bezos, they were example of suborbital flight. SpaceX already has demonstrated this capability. They have a contract with NASA that many of the astronauts which go to International Space Station, they actually are carried by SpaceX capsule. That capsule is carried by their rocket Falcon. So SpaceX already has demonstrated this capability that they can maintain orbital flight. But in any case, these 3 companies have shown, they have demonstrated that they are capable of becoming a player into space tourism as a new sector. And ISRO is also trying to become a player. But for that to happen, we first need to have a successful manned mission. And that is why Gaganyaan ka, jaise for example, when we talk about the benefits of Gaganyaan mission, This can be one of the benefit, that ISRO can become a player into this new emerging sector called space tourism. Which one? Does not have to. It can. Suborbital का carbon line से कोई relation नहीं है. Suborbital simply means that you are not completing one orbit around Earth. It can happen below 100 kilometer, above 100 kilometer also. Maybe 120 kilometer, but it will not be 400 kilometer. 400 kilometer पे आप you can easily attain a stable orbit. So it will be around 100 kilometer, 80, 90, 120, 130. So यहाँ पे carbon line का as such, but main जो definition suborbital flight का simply ये है that you are not completing an orbit around Earth. Without completing an orbit, you are coming back on Earth. बिल्कुल होगा, suborbital flight में भी होगा. The question is that, however, in suborbital flight, because your re-entry, the question is asking is that your re-entry into atmosphere, will it be a problem for suborbital flight also? Yes, it will be a problem, but it will be a less of a problem, because when you are entering from atmosphere, you already are from space, you have a very high speed. So you are traveling around Earth with very high speed, and when you enter, you have to, by the way, apart from the speed, you also need a speed in downward direction. So it depends upon, because जो air drag है, जो atmospheric drag है, it depends upon how much fast you are traveling. In the initial lower speed, जो air drag as a force है, that is proportional to your speed. But at very high speed, it actually becomes square of your speed. That if your speed is twice, then air drag is 4 times. More the air drag, more will be the atmospheric friction, more will be the chance of lot of heat generation and the probability of an accident. So even suborbital flight will have to face this problem. The only thing is that they will face lesser of this problem compared to a typical orbital flight. But even suborbital flight are going to face this problem of re-entry into atmosphere. The next topic is this black hole imaging, which was done by a project called Event Horizon Telescope. So I'm going to divide this into 2 parts. First we will talk about black holes themselves, and then we will talk about what we did in case of Event Horizon Telescope. I do not expect very complicated, very technical question. So very simple understanding of both of these topics within this major topic of black hole is going to be sufficient for prelims examination. Now black holes, as a theoretical concept, the idea is that if I keep increasing the mass and especially density of an object, that mass तो बहुत ज़्यादा बढ़ा सकते हैं, but then it is going to occupy a lot of volume. So if the density of object is very high, that you have lot of mass into a very smaller region, what it means is that gradually what we call escape velocity, that is going to increase. For example, if you have to overcome Earth's gravitational barrier, then you have to attain a speed of about 11.2 km per second. That if I have speed of 11.2 km per second, and if I throw a ball with this speed, for example, from Earth, then this ball is not going to return towards Earth. It will not even orbit around Earth. Less than 11.2 km per second, it will orbit around Earth. But more than or equal to 11.2 km per second, it is not going to return back to Earth. It will make a interplanetary flight. It has sufficient kinetic energy that it has overcome the Earth's gravitational barrier. This speed is called, of course, escape velocity. So this is called escape velocity. Now for heavier objects, of course, escape velocity is going to be bigger. For lighter objects, it will be lighter. For moon, that escape velocity will be 1/6 of that. So yes, about 2 km per second. Even less than 2 km per second. For sun, it is going to be much more than that, because sun is much more heavier than Earth. So if I can find a region into space where the escape velocity is more than 3 lakh km per second, and 3 lakh km per second is speed of light, then we can call this region black hole, because what it means is that even light cannot escape. And light has the maximum speed in the universe. Nothing travels with more than speed of light, as per Einstein's special theory of and general theory of relativity. That the maximum speed any object can attain, that is speed of light, which is 3 lakh km, speed of light into vacuum, which is 3 lakh km per second. And because even light cannot escape from these regions, what it means is nothing can escape. So these regions into space where escape velocity, they are so dense, so heavy that even light cannot escape, they are simply called black holes. So black holes, of course, their gravitational effect is going to be very, very strong. Everything around them. So there are few things, few terminologies with respect to black holes which you should know. And for example, this is a region which is, let's say, this is a black hole. Then around a black hole, there will be a region. And in this region, if anything falls in this region, will directly fall in the black hole. So black hole is this part of the space, but around this, anything which is part of this region will directly fall. ये जो region है, this outer boundary, this region, this is called event horizon. And we can actually calculate that depending upon mass of black hole, we can calculate that what will be the radius of this event horizon. This radius was calculated by a scientist named Schwarzschild. So this is called Schwarzschild radius. But event horizon is a term which ideally you should know because event horizon telescope ke karan. Now if something is beyond event horizon, very far away from event horizon, then it will not directly fall, but there is a very good chance that it can actually drop into black hole and then it is going to directly fall inside the black hole. Or if something is very far away from event horizon, then it can perhaps make an orbit also. It can make a orbit around black hole, but it has to be very, very far away from black hole. So black holes are so dense that जो भी nearby objects होंगे, stars, big stars, planets, all of them, black holes are continuously feeding upon them. Because of this feeding, for example, black holes produce many million kilometers away from their event horizon, they will produce what we call accretion disk. A term is used. Accretion disk. Now accretion disk simply means that we are talking about charged many distant objects, cosmic dust, which is swirling around black hole with very, very high speed. Now they can be seen. जो accretion disk है, that can be witnessed, but you cannot actually see the black hole itself because black hole will not even allow light to escape. If nothing is coming from something, then how can you see it? So you cannot actually look at the black hole, but you can find indirect evidences of a black hole, that there is nothing at the center but still things are revolving around it. So we can call it, we can perhaps an indirect evidence, we can call it that this is a black hole. So around black hole you will find lot of things. For example, accretion disk is one of them. Now accretion disk is simply that around black hole, lot of cosmic dust, lot of other particles, many presence of lot of objects, they were swirling with very, very high speed because of black holes. And that, by the way, that presence of object will be many million kilometers away from this event horizon. So if Schwarzschild radius is r, let's call this r, then accretion disk will be found perhaps beyond 3r, 4r, that many millions kilometers away from the black hole. And you will find lot of particles swirling with very, very high energy, very high speed. And I will come to, let me discuss all these things one by one. Okay? What are gravitational waves? We will discuss करेंगे. So this accretion disk can be actually, that can be witnessed, that can be photographed with the help of very powerful telescopes. This is what exactly we did in the case of Event Horizon Telescope project. तो एक तो सबसे पहली चीज ये कॉन्सेप्ट ऑफ इवेंट होराइजन पता होना चाहिए. जो सेंटर ऑफ ब्लैक होल है दैट इज कॉल्ड सिंगुलैरिटी. सिंगुलैरिटी सिंपली मीन्स that we are talking about infinite density, all of the mass perhaps occupying zero volume. So infinite density, what it will look like, what it will be, we cannot imagine that. Our laws of physics fail there. So the black hole का center है, the entire notion of space, time, everything vanishes here. But black hole का जो center है, That was, by the way, conceptualized by Einstein himself as part of his theory called theory of relativity. So for example, we think that universe started from singularity, that just before Big Bang, universe was in this very hot, dense, infinite density object from a point-like space, and explosion that led to what we witness universe today, 13.7 billion years later. So even universe may have started from a singularity. So in any case, that is about black holes. Now how do they emerge? So there can be actually two types of black holes have been witnessed. One black hole is what emerges when stars die. There is a topic given in your material, although बाद में है, but इसको हम अभी पहले कर लेते हैं. Life cycle of a star. I told you in the last class that stars form from a region called nebula. Nebula has all this cosmic dust. This is page number 45. So nebula has all this cosmic dust, presence of raw material, which can lead to formation of many stars. Now stars can undergo through two different processes depending upon what their initial mass is. And by the way, we should know about it because it was actually an Indian origin scientist named Dr. Subramaniam Chandrasekhar was the first person who actually hypothesized about two distinct stages of star evolution. Dr. Chandrasekhar was very interested in finding out that how stars take birth and especially how do they die. So before Dr. Subramaniam Chandrasekhar, the accepted theory was that all stars are fueled by nuclear fusion, which by the way we have to discuss in one of the topic, and according to me nuclear fusion is a very important topic for this year prelims or mains examination. So in any case, stars are powered by nuclear fusion. Nuclear fusion में क्या होगा कि hydrogen is going to fuse together to form helium. But after a point of time, perhaps few billion years later, most of the hydrogen will be exhausted. Very few hydrogen is left. Whatever is left is only helium. So it leads to formation of what we call red giant star. Red giant because it looks red giant. Now why this topic is given here? Because in our Milky Way there is a very famous red giant star, Betelgeuse. So Betelgeuse red giant star, just remember in one line that there is an object, there is a red giant star in Milky Way called Betelgeuse. This was in news recently. From time to time we observe this red giant star, and it is often covered into newspaper. So it was in news because of that. So in any case, this red giant star is going to lose a lot of its energy because nuclear fusion is not happening. It can lead to a stage called planetary nebula, but frankly it is neither a planet nor a nebula. So it is a misnomer. But it looks like on the earlier telescope when the picture was taken, it looked like a nebula region, so we called it planetary nebula. So what will happen to Sun when all of its hydrogen is exhausted, maybe 4 billion, 5 billion years later? Then Sun का जो outermost layer है, that is going to expand and the innermost layer is going to contract. This expanding outermost layer is going to engulf all the nearby planets, including Earth. So Mercury, Venus, Earth, all of those planets will be engulfed. But don't worry, that will happen about few billion years later. जो internal layer of Sun है, that is going to further collapse. This collapse will lead to more and more nuclear fusion, that now helium nuclei can fuse together and they can form some other heavier element such as carbon. For example, I can have 3 helium forming carbon, and that can lead to formation of what we call white dwarf star. That this white dwarf star is powered by nuclear fusion, and this nuclear fusion is happening because of, and it is producing heavier element such as carbon or even other heavier element. This was the accepted theory, that this is what is going to happen. When all the hydrogen, helium is exhausted, carbon is exhausted, fusion has stopped, it can become a black dwarf star. But for a black dwarf star to emerge, universe has to be older than 13.7 billion years old. So as of now, black dwarf star is a theoretical construct. Nobody has witnessed it. Nobody has find any black dwarf star. This was the accepted theory, that this is how stars emerge and how do they gradually die. But Dr. Chandrasekhar challenged this. Dr. Chandrasekhar felt that for very heavy stars, and in fact he actually calculated that if star is more than 1.4 times mass of sun, then for such very heavy star, जो ये white dwarf है, that is not going to be a stable state. ये जो nuclear fusion है, that will keep on happening, and that nuclear fusion will lead to series of explosions, which are, by the way, considered one of the brightest regions in the universe, called supernova. This supernova explosion will produce, it is one of the brightest region in the universe. It can produce perhaps in 1 second energy more than how much sun can produce in an year. It is so bright. This supernova explosion will also lead to production of lot of other stellar dust particle, and those stellar dust particle will be like raw material for the formation of next stars. But after this supernova, two possibilities are there depending upon how massive the star is. This star has, whatever is left has become so heavy that electrons have now entered into nucleus. They can interact with protons and they can form a neutron. Now I have a material which is mostly made of neutron. This such type of star, they are called neutron stars. So neutron stars are considered to be the second heaviest object in the universe. A neutron star can be lesser than size of Earth, but even 1 millimeter cube of neutron star will be heavier than Earth. It is so dense. So neutron star are considered the second most dense object in the universe. Some neutron stars, they rotate on their axis, and because of this rotation they produce a very powerful magnetic field which can be witnessed even on the Earth, that is called pulsar. There are neutron stars which are much more heavier than an average neutron star, and these neutron stars are called magnetar. So neutron stars themselves are very, very interesting. But there is even more interesting possibility that this star can become a black hole. It has become so dense that even light cannot escape from this star. So that is called a stellar black hole. Now in every galaxy you can find millions of stellar black holes, because in galaxies billions of stars have formed, many have died. So you can find millions of black holes. That is not, frankly, very unique to a particular galaxy. Just even in Milky Way there may be millions of stellar black holes as far as we know. But the black hole imaging, because of that this topic is given in your material, which was done. This black hole imaging actually occurred of a type of black hole which is called supermassive black hole. A supermassive black hole. A supermassive black hole is found at the center of galaxy. Such supermassive black holes, how they have actually been, how they have occurred, we do not have very good theories about it, that how supermassive black holes have occurred. The most accepted theory is that when early stars started dying, they formed many black holes. Those black holes merged together, and that led to formation of bigger black holes. And because of the black holes, nearby stars started moving around them. That moving of stars led to formation of galaxy. So सबसे accepted theory जो ये है, that supermassive black holes and galaxies they formed together. So this is the most accepted theory. But here is a problem with this theory, that the number of galaxies which we witness in the universe is into billions. There are billions of galaxies in this universe, and there is a very good reason to believe that all of these galaxies at their center have a supermassive black hole. So even Milky Way galaxy, which we are part of, has a supermassive black hole at its center. So we have actually done simulations on computer based on our understanding of astronomy, and universe is not old enough to have so many supermassive black holes. So we do not have very good idea that why all of these supermassive black holes have emerged. So this remains a topic of interest. But nonetheless, without any doubt, the most accepted theory, and even that theory is backed by data now, that many galaxies we have witnessed as of now, and many galaxies we have witnessed that there is At their center, there is a supermassive black hole. There can be tiny black holes also. They may have formed when universe began, but they are only theoretical. Nobody had actually witnessed them. But they are only theoretical. Many astronomers believe that very smaller black holes at atomic level may have formed, especially during the initial stages of universe. Now what this project did, जो Event Horizon Telescope project है, first thing first, it is not a project of one organization. जो Event Horizon Telescope है, ये NASA का नहीं है, Europe का नहीं है. This is a collaboration among many agencies. They have funding from many agencies. So this in itself is an independent project. This Event Horizon Telescope, ये किसी एक स्पेस एजेंसी का टेलीस्कोप नहीं है. सबसे पहली चीज तो ये पता होनी चाहिए. Second thing which you should know is that it is not one telescope. It is 8 telescopes strategically located on different part of the earth. जो supermassive black holes हैं, they are millions of light years. Even Sagittarius A, by the way, the supermassive black hole at the center of Milky Way, it is called Sagittarius A. So Sagittarius A is also millions of light years from Earth. And to actually look around that black hole, you need a resolution which is similar to looking at a very small object on the surface of Moon from Earth. That imagine looking at a sand particle on Moon from Earth. You need a powerful telescope like that. And generally, if you need such powerful resolution, you require a very large telescope. So, large telescope as large as Earth itself. Now that is of course theoretically impossible. You cannot make a telescope as large as Earth itself. So what astronomers do is, they use a technology called very long baseline interferometer. In this technology, many telescopes work in tandem in a way that they make one giant virtual telescope in the sky. So all these telescopes, in case of Event Horizon Telescope project, 8 telescopes located strategically at different point on the earth, all of them will collect data simultaneously from the regions of black hole, from the regions of Sagittarius A. And with the help of now many scientists, there will be lot of teams, they will try to make sense of that data, that what picture they have taken. And this process will go on for some time, and finally when everybody has accepted, everybody is agreeing that this is what this data represents, that image will be released. So this did not happen for the first time. In 2019, the same project released image of a black hole, but not the black hole at the center of Milky Way, but another black hole part of another galaxy called M87. So this was the first black hole, which is by the way billions of light years away from Earth, and that black hole was imaged with the help of Event Horizon Telescope project. And the second black hole which has been imaged is the Sagittarius A, which is at the center of Milky Way itself. So few things about Event Horizon Telescope project which you should know. First, it is not under any space agency. This in itself is an independent agency taking fund from many organizations. Second, it is not one telescope, but many telescopes working in tandem and collecting data about Sagittarius A black hole, right? So ये आपको पता होना चाहिए. And third, they are actually not taking the picture of black hole, because you cannot actually take the picture of black hole, nothing comes out of the black hole. They are taking the type of structure which is found around black hole, an accretion disk. So they are taking picture of that accretion disk. And the good thing is that the picture they have taken, that very much matches with theoretical prediction. That if we take picture, many, even before this picture, scientists had speculated that if we take picture, a structure something like this we are going to find. And we have actually found a similar structure. So that also tells you that our understanding of black holes, that is not, error nahi hai bahut zyada usme. So we have a very fair understanding that how black holes will look like if we take picture from a telescope. You should also know this technology, very long baseline interferometry, that is used for many astronomical observation. In this case, we have used it to take picture of a black hole. So I am not very sure. I don't think this topic is important as of now because this is a Nobel Prize in Physics of 2020. But when black hole imaging happened, by the way, so a great scientist, one of the greatest name in physics, is still alive, Roger Penrose. Roger Penrose, he had predicted that if Einstein's general theory of relativity is correct, then black holes can easily exist. बहुत सारे साइंटिस्ट जो उनको लगता था कि ब्लैक होल इज ओनली अ थ्योरेटिकल कंस्ट्रक्शन, इट इज नॉट प्रैक्टिकली पॉसिबल, बट रॉजर पेनरोज मैथमेटिकली showed that it is actually a possibility. And when black hole imaging happened, Roger Penrose was also given Nobel Prize in Physics. And Andrea Ghez and Renard Genzel, they also received this Nobel Prize because they were the first who actually looked at the data collected from some telescope, and they were the first who came to this conclusion that at the center of galaxies you have supermassive black holes. So this happened, by the way, in 2020, so I don't think this is important, frankly. But nonetheless, जो Event Horizon Telescope project है, what it is and what it did, the terms like Event Horizon, Singularity, Schwarzschild Radius, ये सारी चीज़ें आपको पता होनी चाहिए. Any question in this topic? कोई डाउट ही नहीं है. इन जनरल हमको पता होना चाहिए कि जब भी हम कोई भी इमेज हम ले रहे हैं, एनी टेलीस्कोप, फॉरगेट दैट, आप जब स्टार्स को देख रहे हो, व्हेन यू लुक एट स्टार्स इन द नाइट, देन यू आर नॉट लुकिंग एट दैट स्टार व्हाट इट इज राइट नाउ. दैट लाइट स्टार्टेड coming, if let's say for example, even if you are looking at let's say Proxima Centauri. So Proxima Centauri is the nearby star compared to Sun. It is about few light years, I think 3-4 light years away from Earth. So if you, even if you are looking at Proxima Centauri, then you are looking at Proxima Centauri what it was 3 or 4 years ago, because that is the time it is going to take for that light to arrive on Earth. So in general, whenever you are looking in the sky, you are looking in the past in that sense, that the light, whatever time it is going to take for a particular light to come, whenever you are looking at distant object, you are looking in the past, including sun. If you are looking at the sun, then you are not looking at exactly sun is at right now, you are looking what it was 8 minutes ago, because that light will take about 8 minutes to reach on Earth. So ये हमेशा clear होना चाहिए कि whenever we are looking at distant object, in a way we are looking in the past. There is a, देखो छोटे छोटे टेबल में बहुत सारी चीजें लिख देते हैं मटेरियल में करते रहो. So by the way, this question was actually asked by UPSC, that is why they have included. But this question was asked by UPSC because it was covered into newspapers. Newspapers में covered था इसलिए आया था. So there is a very famous theory of physics called general theory of relativity. Einstein is considered one of the greatest physicists along with Newton who has lived on this planet. Einstein is very famous for two theories. One is called special theory of relativity, another is called general theory of relativity. I will briefly mention the main points about special theory of relativity and general theory of relativity. Special theory of relativity tells you that this entire notion of space and time, how we think that time is absolute, that is not true. Space is not absolute, or space is absolute, that is also not true. What it means is, अभी तक laws of physics are relative, ये बहुत पहले से clear था. वो गैलीलियो को भी clear था, न्यूटन को भी clear था कि same चीज़ को अगर हम अलग अलग frame of reference से देखें, so we are going to witness two different things. Imagine a situation that I am into a truck which is accelerating. Now in my frame of reference I am at rest. Everything else is moving in the backward direction. तो मेरा जो observation होगा, that is going to be different compared to an observation made by a person who is on rest, on standing on the road. So this thing was very much clear that observations made by different frame of reference will be different. It was clear to Newton also, it was clear to Galileo also. But they both agreed, or in fact many scientists before Einstein, they agreed that the concept of time is absolute. What does that mean? That any type of time, whatever, whoever is measuring time, the same time will be measured by each and every observer in this universe. A very simple example is, if I drop this pen, and let's assume that this pen dropped in 1 second from this height to this height. Now all of us are saying that this 1 second will be measured by each and every one on this planet, each and every one in this universe. This time that it has passed, this event has happened into 1 second, is absolute for each and every observer. Einstein challenged it. Einstein said that that is not true. It actually depends upon how fast you are moving. So आपका जो velocity है, that will tell you that what length or what time you are going to measure. Another example, if I say that these 2 points are separated by, let's say, 1 centimeter, then I am saying that 1 centimeter is same observation will be done by each and every one of us. All of us are going to measure that this distance is 1 centimeter. Einstein says that that is not true. It actually depends upon how fast you are moving. So especially if you are moving very fast, closer to speed of light, then you are going to measure this as a different distance. So the concept of space and time, which we think to be independent of each other, Einstein says that that is actually not true. Space and time are very much related upon each other. In fact, Einstein says that time is another dimension. So we are actually living into a 4-dimensional universe, where I have 3 spatial dimensions, x, y, z, but time is the 4th dimension. The difference here is, of course, that while in space I can go up and down, left and right, back and forth, but in time I cannot go backward. In time I always move forward. So that is the difference. But apart from that, time is very much like a dimension, very similar to spatial dimension. So we are living into a 4-dimensional world. And the basis of Einstein's theory of special theory of relativity is a very important fact that the velocity of light hai, that remains constant in every frame of reference. This was actually asked by UPSC last to last year, that why do we measure things into light year? एक simple सा question था, that why do we measure things into light year? जो भी distant objects हैं, we measure them into light year. Light year is a unit of distance. I hope that is clear to everyone. So why do we measure everything into light year? And the reason is very simple, because light का जो velocity है, that is a law of physics, and light का velocity in every frame of reference will remain exactly same, which is 3 lakh kilometer per second. Now what it means is, imagine a situation that there is a person 1 and there is a person 2. This person is traveling with, let's say, 4 kilometer per second. This is traveling with 4 kilometer per second, however in opposite direction. And in another situation, both of them are traveling with 4 kilometer per second, but in the same direction. So if I use the concept of relative velocity, then this person 1 is at rest in its own frame of reference, and what this person 1 is going to find, that is जो 2 है वो 8 km per second से भाग रहा है, because both of them are separating from each other. So the relative velocity of 1 with respect to 2 is going to be 8 km per second. In the second case it will be 0, because both of them are traveling in the same direction. जो इनका distance है, same distance they are going to maintain throughout their motion. Their relative velocity is 0. Einstein says that convert this into c, 3 lakh kilometer per second, that is speed of light. This c, this c, this c. Now 1 is going to measure speed of 2 at c only, not 2c, not 2 times speed of light. 2 is going to measure speed of 1, again c, not 2c. In this case also not 0, again c. So the relative velocity, if it is speed of light, that is going to be c throughout if you measure in any frame of reference. This became the basis of Einstein's special theory of relativity. So this was asked by UPSC that why we measure things into light year, and the answer is very simple, because velocity of light remains same in all frame of reference. कोई भी frame of reference ले लो, velocity of light जो space में है वो same रहेगा. Of course in a medium it is going to decrease, but that is generally whenever we talk about large distances, astronomical distances, we are assuming that most of this astronomical distance is filled with vacuum, right? So that is why light year is a very good unit of measuring large distances. Einstein's general theory of relativity went one step ahead. So this was special theory of relativity, that space and time, they are related to each other, and that leads to different observation of time, different observation of space. But in general theory of relativity, Einstein further hypothesized that entire space-time is also affected by gravity, that time passes differently near different objects. For example, how time passes on Earth is not same as how time passes on Sun, and is also not same how time passes on, let's say, near a black hole. So time passes differently. For example, if I have stayed for some time on Sun and I have come on Earth, then more time will pass on Earth. That difference is very less if I'm talking about Sun and Earth, but nonetheless there will be a difference. But if I, let's say for example, stay some time around a black hole and come back on Earth, then there is a chance that many years have passed on Earth, but on black hole only perhaps few minutes have passed. So time also depends upon, this entire concept of space and time also depends upon gravity. That was hypothesized by Einstein in his general theory of relativity. And the general theory of relativity here, that actually predicts a lot of other things. So first, I will briefly summarize. that जो spatial theory of relativity है, first it is based on this idea that this velocity of light जो है is absolute. This velocity of light is not going to change into any frame of reference. That leads to this concept that space and time are very much dependent upon each other. What it means is that this entire concept of absolute time or absolute space is meaningless, because even space and time are relative. Different observers will measure different length, they will measure different time. The relative velocity is also going to be different compared to how fast they are moving. So it leads to a lot of phenomena such as what we call length contraction, or time dilation. And the idea is that we live in a 4D world where I have 3 spatial dimension plus 1 time dimension. That is the consequence of Einstein's spatial theory of relativity. So general theory of relativity है. First thing first, general theory of relativity is a theory of gravity. Einstein, even before Einstein, जो Mercury का orbit है, people try to predict the Mercury's orbit using Newton's ideas, and they realize that Newton idea is not able to predict it properly. So people thought that maybe there is some problem, maybe our data is wrong. But Einstein modified Newtonian's gravitational theory in his general theory of relativity, and his theory became perfectly, it explained that why Mercury orbit is different compared to what it should have been. So frankly, it is a theory of gravity, and जो fundamental basis है इस theory का, that gravity affects space-time. First, space and time are not different from each other, and they are affected by gravity. What it means is that if I am near a very massive object, the time dimension or the जो spatial calculation मेरा होगा, जो temporal calculation होगा, that will be different compared to if I am near a lighter object. But it also predicts a lot of other things. For example, it predicts existence of black hole, and we know that to be true. It predicts that universe is expanding. Now, why UPSC did ask this question on general theory of relativity? I will tell you a reason. Einstein, when he came to this conclusion that his theory is predicting that universe is expanding, he thought that his theory is not correct. He thought that there is some problem with this theory. He actually thought that it needs some modification. But when later observations pointed out that it is actually true, then Einstein realized that he has made a blunder. His theory was accurate, his assertion was wrong. What he had theorized as per his general theory of relativity, that was actually accurate, and what he thought it shouldn't be, that was wrong. Einstein called it one of his greatest blunder. And that actually occurred with the help of very powerful telescope. Some years have passed, people were celebrating this discovery, and because of that many newspapers had covered this, that one of the aspect of Einstein's general theory of relativity is that universe is expanding, and that is why UPSC did ask this question, that what are the predictions of Einstein's general theory of relativity. So first, light can be affected. Another impact can be that light can be affected by gravity. Another consequence can be that gravitational waves exist. All of these are consequences of Einstein's general theory of relativity. And all of them now we know to be true. Einstein was not recognized for this theory because there was no way to confirm it. So Mercury ka jo orbit hai, that was also anecdotal proof. It was not very clear that if it is because of Einstein's theory or maybe some other reason is there. So Einstein did receive Nobel Prize in Physics, but for a very small discovery called photoelectric effect. For his special theory of relativity and general theory of relativity, he never received any Nobel Prize. But now we know that his theories were correct. Somebody had a question. It simply means that I am, for example, imagine I am walking. Now in my frame of reference, I am a conscious being, I know that I am walking. But if I have to calculate in my frame of reference, actually your position is changing. If you think about it, right? In your frame, so every object is in rest in his own frame of reference. That has something to do with Einstein's theory of relativity. उसको हम दिखा सकते हैं, but ज़रूरत नहीं है, बिल्कुल भी ज़रूरत नहीं है, ठीक है? किसी को बोलना ज़रा, someone from admin team, शायद AC काम बंद कराने, किसी को बोलिएगा ज़रा. Another topic which is given in your material is about gravitational waves. I will come to that also. Tidal disruption event क्या है, वो भी हम discuss करेंगे. Gravitational waves are simply disruptions into gravitational field. Yes, electromagnetic waves are disruptions into electromagnetic field. For example, this light is nothing but a type of electromagnetic wave. Or when we talk on phones and our voice is being transferred with the help of radio wave. Now radio wave is also an example of electromagnetic wave which travels with speed of light. Very similar to that, there can be disruptions into gravitational field. And those disruptions will produce what we call gravitational waves. These gravitational waves also travel with speed of light. That was predicted by Einstein. Now here is the thing, gravitational waves will also occur if sun is accelerating, and sun is accelerating. The thing is that gravitational wave produced by sun will be so small that we cannot detect it. For actual detection of gravitational wave, we require some powerful events. We require perhaps two black holes merging, or a neutron star merging into a black hole, or a supernova explosion. So such type of cataclysmic event can lead to disruption into gravitational field, and that can produce gravitational wave. And those waves, even if they are being produced millions of light years or billions of light years away, can be felt on Earth. So it was actually detected in 2015 for the first time by a detector called LIGO. Now LIGO is actually made of two very large mirrors, L-shaped mirrors, very large mirrors, 1.5 kilometer, like a L-shaped mirror. Now जो gravitational waves हैं, because we have discussed that gravity affects both space and time. So the gravitational waves हैं, they also affect both space and time. So the idea behind this setup is that if gravitational waves are passing through this setup, if there is any change of its length, first vertically, second horizontally, and even if that change is very small, it can be measured. Now why this change will occur? This change can also occur because of thermal expansion. अगर temperature बढ़ता है तो change होगा, temperature कम होगा तो change होगा. So we ensured that the temperature of this setup remains throughout our experiment remains same. Temperature does not change. And जो भी temperature change होगा, that will actually lead to different type of disruption vertically or horizontally. So whenever a gravitational wave is passing, gravitational wave is going to contract and stretch the space itself as it travels. That space is being contracted and it is also being expanded. What it means is that whenever gravitational wave is passing through, there will be small changes into its vertical and next into its horizontal length. And even if that change into let's say micro or nanometer level, even that change, you had sensors here that change can be monitored. And this was predicted by Einstein in 1915, 1917. And almost 100 years later, it was discovered for the first time by this detector called LIGO. It is situated in USA. That it actually detected that gravitational waves, जो prediction था Einstein का, that is accurate. So a vibration into space-time itself, which travels with speed of light, and even though smaller objects, sun for example, for gravitational waves, sun is a smaller object. Even smaller objects produce gravitational waves, but that wave is so small that we cannot detect it frankly. But if there are cataclysmic events, like a supernova explosion, a star dying, or two black holes merging, or a neutron star black hole merging together, such type of cataclysmic event produces gravitational waves, and that can be detected even on Earth, even if they have been produced millions or billions of light years away. And this detection occurred for the first time in 2015 by LIGO detector. There is another very famous detector which is under construction. इस पे भी UPSC ने क्वेश्चन पूछ रखा है, called LISA detector. LISA detector is being planned by European Space Agency. यहाँ पे same type of setup, but into space they are going to create. They are going to create basically 3 satellites with very powerful mirrors, an interferometer, and they are going to make like a triangular shape. And that triangular shape का जो side होगा, that will be few million kilometers. So 3 satellites will be kept with powerful mirror, and their side will be about 1.5 million kilometer distance, and they will maintain this same distance throughout their journey. If there is a gravitational wave, there will be change in that distance, and that distance we can actually calculate. So this is the idea European Space Agency is working upon. This detector is called ELISA. UPSC ने यूं का यूं क्वेश्चन पूछा था that a space agency is planning to launch mirrors into space, and those mirrors will form a triangle, and वो triangle का जो side होगा, that will be about 1 million kilometer. What is this detector called? And the answer was ELISA. And the purpose of ELISA is to to detect gravitational wave. So the objective of ELISA is to detect gravitational waves. Sorry? No, gravitational waves can be disruption in gravitational field. जैसे if charged particle is accelerating, charged particle can produce electric field. The same particle, if it is moving, it produces magnetic field also. But if charged particle is accelerating, then there is a disruption into their electromagnetic field. So that produces what we call electromagnetic wave. So if charged particle is accelerating, that produces electromagnetic wave, because it is a disruption into electric field and magnetic field. Similar type of disruption can be produced into gravitational field. But the only thing is that gravity is very weak. Electromagnetism is a very strong force. Gravity is very weak. So disruption into gravity, if it is happening because of a smaller object, it cannot be detected. But if it is happening because of cataclysmic events, then yes, it can be detected. So no, it is not just falling down of objects into black hole. It is in fact 2 black holes perhaps colliding together. That can lead to production of black hole, gravitational wave. ये भी क्वेश्चन आया था यूपीएससी का. that few events such as supernova, collision of black hole lead to production of what? The answer was gravitational wave. LIGO पे यूपीएससी ने क्वेश्चन नहीं पूछ रखा है, बट LIGO के बारे में भी आपको पता होना चाहिए. दिस इज अ वेरी फेमस डिटेक्टर, an L-shaped detector which became the first detector to detect gravitational wave in 2015. Sorry, म्यूऑन टोमोग्राफी के कॉन्टेक्स्ट में आप बोल रहे हो? आई एम वेरी श्योर कि अपडेटेड मटेरियल में कवर होगा, तब डिस्कस करेंगे, बिकॉज राइट नाउ अभी है भी नहीं किसी टॉपिक में. उसके लिए थोड़ा सा हमको पार्टिकल फिजिक्स के बारे में समझना पड़ेगा. So that is entirely a separate topic compared to what we are discussing right now. So LISA Pathfinder is a precursor mission of this ELISA. So LISA Pathfinder, European Space Agency did this first on Earth, that let's try to understand if this on Earth it works, and then their actual plan is to send this into space, right? So जो LISA Pathfinder है, नाम में से दिख रहा है Pathfinder. So LISA Pathfinder is paving the way for this actual setup called ELISA. So that was one of the option, by the way, LISA Pathfinder, but the answer was ELISA. हाँ, that is actually true. हाँ, ये you should know this. LIGO एक और कारण जो हमको पता होना चाहिए LIGO के बारे में, that पहले तो जो LIGO सेटअप है वो यूएस में था, बट नाउ LIGO जो सेटअप है दैट इज एक्चुअली कोलैबोरेटिंग विथ मेनी अदर कंट्रीज, एंड जो ग्रेविटेशनल वेव डिटेक्टर्स हैं दे आर एक्चुअली बीइंग कंस्ट्रक्टेड ऑलरेडी फंक्शनल इनटू सम कंट्रीज. फॉर एग्जांपल इटली में एक डिटेक्टर है विच इज कॉल्ड वर्गो, जापान में एक डिटेक्टर है, एंड इवन इन इंडिया a gravitational wave detector is under construction in Maharashtra. So there is actually a LIGO India facility, that is, thanks for telling me. So there is a LIGO India facility into Maharashtra as of now with same objective, detection of gravitational waves. That is Neutrino Observatory. Any other question till now? There is a small topic given here. Called tidal disruption event. The most obvious thing which I will just remember this in this topic is that it occurs because of black holes. But let me tell you what happens. If I assume Earth, assume this is Earth, and assume there is a very large object falling vertically on Earth. From some height, there is a very large object falling vertically on Earth. If you think about it, then the distance of this part of this vertical object and distance of this part of this vertical object are not exactly same from Earth. ये जो length object का खुद का length है. Now हमको ये भी पता है कि जो gravitational force है that depends upon distance. So this part of the object is closer, this part of the object is farther away compared to Earth. So in a way, they are experiencing different amount of gravitational force, because gravitational force is m1 m2 by r square. It actually depends upon the distance. But Earth is, frankly, compared to other celestial object, Earth is a very small object. So we can easily neglect this difference, that if this force is, let's say for example here, if this force is F1, and here if this force is F2, then F1 is equal to F2 for all practical purposes. There is no problem here, even though technically F1 will be little bit greater than F2. But that difference I can easily neglect, I can simply call it to be equal. So I do not have to bother about the length of this object. Now replace Earth with black hole. This is not Earth, this is a black hole, and there is an object falling like this. Even if this is a very small object, this very small length will actually lead to entirely different gravitational force. The gravitational force near this object and farther from this object will be very, very different. This object will be shredded because it is going to feel this gravitational force, which is going to be different. This shredding of object as something falls towards black hole, because the object's length are different from the black hole. The shredding of this phenomena, this is called tidal disruption event. So if a black hole is feeding on a nearby star, then star is a giant object in itself. जो nearer part of star है that is being fed much faster, जो middle part of star है slower, and the farthest part of the star even slower. So it is going to rip this star apart atom by atom, but it is going to do into a shredding event, a shredder sort of thing. And another term is used for it called spaghettification, because there is a very famous Italian dish spaghetti जहाँ पे ये मैगी की तरह basically होता है. So something like this will happen, that entire star will be converted into this smaller spaghetti noodles. So this event is called spaghettification, and another proper term is tidal disruption event. Okay? And why we call it tidal disruption event? Because of the same reason why tides occur on Earth. Because if you think about it, tides occur on Earth because one part of Earth feel different gravitational force compared to another part of the Earth. And what we call tide, if you think about it, that a part of this part of Earth is feeling different gravitational force from Moon, this part of Earth is feeling less force, that leads to these two bulges which occur because of ocean, and in this bulge Earth is moving around. So if you think about it, if you change your frame of reference, you had a question about frame of reference. If I could see Earth from outside, then what I am going to find, that there is already these two bulges, and in this bulge Earth is rotating. Because Earth is rotating in this bulge, whenever this part will come here, will feel high tide, and when this part will come here, will feel low tide. So we have this periodic high tide and low tide event, because in a way, जो tidal bulge है, we are rotating in it. But in our frame of reference, we are saying that ocean water ऊपर जा रहा है, नीचे आ रहा है. That there is a tide rise, high tide, and there is a low tide. So that is how frame of reference changes your perspective. But in any case, the reason we are calling it tidal disruption event is very similar to why tide occur on Earth. Because ये जो दो bulges हैं, these two bulges occur because Moon has different gravitational effect on the water near it and farther from it. Same term, जो tidal disruption event है, where a star is being shredded, ये जो noodle type shape बन रहा है ना, this event is called spaghettification. And this word is taken from an Italian dish called spaghetti. There is an Italian dish called spaghetti, looks like a noodle. So this is this phenomena, that how a black hole can shred things apart, is called spaghettification. So in any case, the most accepted question for me will be this term given, and asking, UPSC is asking that what this term describes, and one of the answer will be, one of the option which will be the correct, is black hole feeding on a nearby object such as star. Simple. Another important concept, two important concepts called dark matter, dark energy. यहाँ पे context क्या है? That there is a detector called LZ detector in US. तो context पता होना चाहिए. There is a detector called LZ detector. There are many such detectors all across the world. So those detectors which are in use for any reason, we should know about them. They are trying to detect dark matter. What exactly is dark matter? So, sorry? Bhoot Pishach, something like that, right? So dark, which topic? Which topic is left? डिस्कस तो किया हमने ब्लैक होल्स. हाँ जी बोलिए. हाँ प्लीज आस्क. The word tidal, why we are calling it the word tidal? Because we use the concept tide जो है. Why tide emerges, मैं वो समझा रहा था. So tide emerges because the part of Earth which is facing towards Moon. Earth is a very large object compared to Moon, right? Earth has a radius of 6400 kilometer. So the part of the earth which is facing towards moon, now here is the thing, we moon का एक ही part हम हमेशा face करते हैं, but that is a separate thing. The part of earth which is facing towards moon and oceans around it, they are going to feel different gravitational force compared to the part of the ocean which is away from the moon. Because of that, bulges will be created. One bulge, another bulge. So this is called tidal force. So tidal force simply emerges. Why tidal force? Tidal force has a simple meaning, that if I'm talking about distance, same object, but same object is a larger object, and it is that larger object is at different distance from a gravitational source. But because this is a larger object, one part of the object will feel different gravitational force, another part of the object will feel different gravitational force. ये जो difference है, that leads to what we call tide. So tide has a very specific meaning, that same object experiencing different gravitational force. So in the case of why we are calling it tidal disruption event in case of black hole, because if a black hole is feeding upon a star, then the part of star which is nearer to black hole, it is going to feed that much faster compared to the part which is farther and farther away from the star. So it will rip this star layer by layer, and this ripping apart of that star, I am calling it tidal disruption event, or we can also call it spaghettification. Sorry, which topic is left? Tidal disruption event. ये कहाँ पे दे रखा है? Gravitational waves. Acha, two supermassive. I already told you that two supermassive black holes, binary supermassive black holes, if there are two supermassive black holes which are close to each other. So that is not important. What is important here is this word called blazar. So I told you that I can have what we call supermassive black holes. Supermassive black holes are generally much bigger than a typical stellar black hole. Now there are two things which are witnessed in a galaxy called quasar and blazar. They are basically same thing. Quasar is a bigger word, blazar is a type of quasar. So what is quasar basically? That certain galaxies, scientists have witnessed that certain galaxies, उनका जो supermassive black hole जो center पे है, that supermassive black hole is accelerating lot of nearby object, because as they fall, before falling, they are going to be accelerated. We are talking about very giant objects accelerating towards black hole. That acceleration will produce lot of energy, and that production of energy leads to often some of the brightest region in the universe. The brightest, in fact. So I told you supernova black holes, supernova explosions are one of the brightest, but they are frankly much dimmer than what we call quasar. So quasar is that there is an active galactic nuclei, that at the center of a galaxy you have a supermassive black hole, and that supermassive black hole, as it is feeding upon nearby object, and as those objects fall, this falling off, it leads to a lot of acceleration, and that acceleration releases a lot of energy back into this universe, and that energy is called, that very bright region of this active galactic nucleus, it is called quasar. And a type of quasar which is directed towards Earth, by the way, which can be witnessed directly coming towards Earth from telescope, we call it blazar. So blazar is also a type of quasar. Quasar is a larger word, blazar is a smaller word. So such type of feeding of things by supermassive black hole, that can also produce gravitational waves. So, and those gravitational waves, by the way, can be detected. So the key word which you have to remember here is blazar or quasar. Quasar simply, if I have to define this in one line, an active galactic nucleus powered by supermassive black holes. just awareness about this term is more than enough, and especially and only important for prelims examination. We can. That is in fact it becomes one of the indirect evidence. The question is no application तो हम नहीं use कर सकते because despite the fact that it is so bright coming from far away, we cannot use it for any technology. But it will not actually tell you image of any region per se. When we talk about imaging of a region, and by the way, quasar you cannot always witness it. Quasar in certain galaxies you can witness it, and you can find it, and that gives you an indirect evidence of a black hole. That a very bright region at the center of galaxy, which by the way far away from a supermassive black hole, I can call it quasar. But quasar cannot actually give you the image around the black hole, because we are talking about an area millions of light years into sky falling into a black hole. So it cannot actually give you an idea about the region around black hole. So when we talk about the black hole imaging, we often take the picture of this accretion disk which is found around black hole. Powered का simply मतलब है कि supermassive black holes are so powerful that as things fall, they get accelerated. And this acceleration produces all of this bright light back into the universe. So in that sense, they are powered by, that is quasar. नहीं, ब्लेजार, सो क्वेजार का ओरिएंटेशन अलग अलग हो सकता है कि हम किसी चीज़ को जैसे इमेजिन करो कि एक लाइट बिल्कुल आपकी, आप रोड पे जा रहे हो, आप एक रोड पे जा रहे हो, एक कार बिल्कुल आपकी तरफ आ रही है, दैट इज़ अ कार. आप एक रोड पे जा रहे हो, देयर इज़ अ पैरेलल परपेंडिकुलर रोड टू इट, एक कार आपके परपेंडिकुलरली जा रही है, उसका भी लाइट है. You can witness that light also. You can also witness light which is coming opposite to you. So blazar will be that car coming opposite to you, and quasar in general will be that car which is going perpendicular to you. So light which is moving parallelly to you, perpendicular to you, I can call it quasar, but that same thing coming towards Earth, I can call it blazar. So quasar is a bigger term, blazar is a subtype of it. Dark matter, this is also a very talked about word. So scientists found lot of anomalies in the astronomical calculation. There are many examples, but I will give you the most famous example which actually became the basis of dark matter as a theory. The most famous example is that we know that at the center of galaxy there is a supermassive black hole, and around this supermassive black hole stars are revolving, very similar to how there is sun at the center of solar system and planets are revolving around it, and all of that is happening because of gravitational force, because of sun. Now here is the thing, we know it for a fact that planets which are very far away from sun are revolving over. Mercury revolves in few months, Earth revolves in 365 days, Pluto hasn't completed, Pluto by the way is not a planet, but Pluto hasn't completed even one revolution since its discovery. So डिफरेंट जितने ज़्यादा हम दूर चले जाएंगे सन से, जो प्लैनेट का रिवोल्यूशन है वो स्लोअर होते चले जाएगा. बट सो साइंटिस्ट थॉट दैट सिमिलर टाइप ऑफ थिंग शुड ऑल्सो बी विटनेस्ड इनटू अ गैलेक्सी, दैट स्टार्स विच आर वेरी फार अवे फ्रॉम द सेंटर, which by the way is a supermassive black hole, then they should revolve much slower compared to the stars which are nearer to that center. And they calculated with this assumption, but this calculation pointed out that even very farther stars, and not in one galaxy but in many galaxies, even very farther stars are actually moving with very high speed which cannot be predicted with the help of understanding of gravitational force. Now there are two possibilities. One possibility is that our understanding of gravity is not correct. There are, by the way, scientists who think that that is one theory. Or second is that maybe there is another source of gravitational force, we cannot see it, but that source is there. Why we cannot see this? Because it does not interact with normal light. So that another massive or objects with mass, we call it dark matter. That we are talking about objects which do not interact with light, do not interact with any electromagnetic wave, forget visible light, any electromagnetic wave. Because of that we cannot see them, but we can feel their gravitational presence. this has become a very accepted theory. So there are many astronomical observations like this, which tells you that the amount of mass which is present in the universe, it shouldn't make a stable universe. What it means is that there is much more mass which is present, and that mass does not interact with light. Because of that we cannot see it. Nonetheless, there may be some indirect methods to detect them. So there are many detectors on Earth right now who are trying to detect dark matter. One of the famous detector is this detector called Lux Zeppelin or LZ detector, one of the most sensitive detector on Earth right now. So dark matter as of now is only a theoretical construct. Nobody has verified it if it exists or not. But this is a very accepted theory because the concept of dark matter very well explains lot of gravitational anomalies which we actually witness. But by the way, there are alternative theories also. For example, a theory given by some Israeli physicist who consider that जो Newton का gravitational force है, that needs to be modified from very larger reason. That is called modified Newtonian dynamics. So that is also a theory, but nonetheless acceptance of dark matter is much more compared to this modified Newtonian dynamics. So dark matter as of now, I will repeat, it is only to explain gravitational anomalies. There are many gravitational anomalies. One of the anomalies I explained is that stars very far away from the center of galaxy still moving much faster. So that is a gravitational anomaly which can be explained with the concept of dark matter. But nobody knows what this dark matter is, what it is made of. Nobody has any idea about it, and that is what we are trying to do on Earth, that we are trying to detect them with many detectors, including this detector called Lux Zeppelin detector. So only two things I will remember from this topic. First, there is a detector called Lux Zeppelin detector to detect dark matter. Second, what exactly is dark matter? ये दो चीजें अगर आपकी क्लियर हैं तो आई डोंट थिंक इससे ज़्यादा ज़रूरत है प्रीलिम्स एग्जाम के लिए. नाउ द कॉन्सेप्ट ऑफ डार्क एनर्जी. सो इफ डार्क मैटर, चलो फिर भी बहुत सारा क्लैरिटी है. Clarity in the sense theoretical clarity. Practically we haven't actually found that if it is there or not, but still there is a lot of theoretical clarity about dark matter. Now here is another observation which does not fit into our understanding of universe. All of us know that universe is expanding. बहुत सारे experiments हैं, बहुत सारा data है which points out that universe is expanding. Now expanding universe, but because galaxies are very heavy, so galaxies have an attractive force because of gravity. So that attractive force ideally should slow down this expansion, because even though things are moving far away, but gradually this expansion should slow down because of the attractive forces between galaxies. So scientists thought that let's measure the rate of expansion, and to their surprise, forget slowing down, they actually found out that not only universe is expanding, but it is expanding with more and more rate. That rate of expansion in itself is increasing. That universe is expanding, but expanding even more as time progresses. Now what is that source of energy which leads to this expansion or accelerated rate of expansion? We call it dark energy. But what it is made of, there are many theories, but none of them are acceptable. Many physicists have different type of theories that what is the source of this dark energy, but first we do not know, there is no acceptance frankly around this theory. So dark matter खुद में mysterious है, but dark energy और भी ज़्यादा mysterious है, that it is used by scientists to explain accelerated rate of expansion of universe. And this accelerated rate of expansion of universe, it's still a mysterious, it is there, we know it to be true, but why is it happening, we do not know that, and we use this concept of dark energy to explain that. So that's it. इसके अलावा और कुछ भी जानने की हमको ज़रूरत नहीं है. So dark energy in one line, if I have to write down, it is in one line to explain the accelerated expansion of universe. That's it. And one more thing, because we do know that both mass and energy are, by the way, Einstein का जो special theory of relativity है, I told you many consequences. One of the consequences of special theory of relativity is that even energy and mass are manifestation of same thing. This very famous formula called E is equal to mc squared, कभी ना कभी पढ़ा होगा, right? E is equal to mc squared. हरियाणा से हैं आप तो सुना भी होगा आपने mc squared को, but जो E is equal to mc square है, that basically tells you that both mass and energy, they are manifestation of same thing. This is also a consequence of special theory of relativity. So if I include all of the mass and all of the energy of universe, then about 68% of universe is dark energy, about 27% is dark matter, and only 5% is this visible matter, which are stars, planets, etc. But most of the universe is dark energy, then dark matter, and then visible matter. Percentage is not important, but this decreasing order, if you want to remember, you can do that. Sorry? ग्रेविटी का कहाँ? ग्रेविटी तो सबसे पहले तो ग्रेविटी जनरल थ्योरी ऑफ रिलेटिविटी में ग्रेविटी फोर्स भी नहीं है, बट मैटर एंड एनर्जी की हम बात कर रहे हैं. यहाँ पे ग्रेविटी क्यों फिट बैठेगा? Forget it. Dark energy is not a force per se. Dark energy is the source of that force which repels, which basically leads to this accelerated rate of expansion. But it cannot be called as such a force, but an agent behind this force. Somebody had a question. Not necessarily. Who told you? No, not at all. Not at all. अगर ऐसा होता तो फिर तो dark matter will not allow any light to pass through. So even theoretically, dark matters cannot be considered to be denser than black holes. लाइट इमिट नहीं करना और लाइट से इंटरैक्ट न करना दो अलग अलग चीज़ें हैं. ब्लैक होल्स आर सो डेंस दैट दे डू नॉट अलाउ लाइट टू एस्केप. Black hole and dark matter does not interact with light. That is a different thing. Interaction with light depends upon properties, and different objects have different type of interaction with light. इसको सबसे simple तरीका समझने का ये है that if I have a torch and I use it on wall, it is not going to cross this wall, isn't it? So this wall is opaque for visible light. But if I have my mobile phone, I can talk to someone inside this room even if all the walls and doors are closed, because for radio wave ये जो wall है ये transparent है. So radio waves के लिए ये wall जो है ही नहीं, it is transparent. So imagine it like this. So different objects have different type of interaction with different type of light. Dark matter has no interaction with any type of light. That's it. That is different from saying that it does not allow light to escape in the same way how black holes do not. Any other question? Let's take a break here. After that, we will resume the class with other topics. This next topic, which is given Earth records shortest day. There are only few things which you have to know about this topic when we talk about Earth's record shortest day. Shortest day, for example, day and night we measure because of Earth's rotation around its axis. This Earth's rotation around its axis, which happens in 24 hours, not exactly happens in exactly same time. Because Earth in itself is a body which is rotating, because it was always rotating in the past. But nonetheless, changes on Earth's surface or inside the Earth's surfaces can actually change that rotation. I will give you a very good example. When China started constructing some of their largest dams, because of that, so much of million of liter of water accumulated into a region around China that actually changed the Earth's rotational speed. So small changes here and there, volcanic eruption or any type of changes here and there which occurs on a much larger scale can have some impact on Earth's rotation, and because of this Earth can rotate faster or slower. So changes which are happening on Earth or inside Earth can have some impact. How Earth's mass is being distributed across its axis of rotation can have some impact on its rotation. This occurs because of a very famous theory in physics called conservation of angular momentum, that how masses are distributed across center of axis or axis of rotation. Depending upon that, I can have faster or slower rotation. आप इसको बहुत intuitively आप समझ सकते हो इस example से. When you played as a child on swing, जब आप झूले पे झूल रहे हैं, then on swing, if I have to increase my rotational speed, all I need to do is basically keep my legs back and then again stretch them back. Just keep doing that and you can keep increasing your speed. So what you are doing here is that you are changing your mass distribution with this axis of rotation, and by doing that you can keep increasing your angular speed. So this is a consequence of conservation of angular momentum. Or if, for example, let's imagine that if I have two dumbbells in my hand, I am rotating on this chair, and if I just keep my hand back while rotating, I will start rotating faster. So how my mass is changing from this axis of rotation, depending upon that, my rotational speed can increase or decrease. Again, if I keep my hand back, again my rotation is going to slow down. So even on Earth, it is possible that how if you have significant mass disturbances here and there, it can slow down or fasten the Earth's rotational speed. Because we calculate our time based on Earth's rotation, so from time to time, if Earth's rotation has changed a lot, from time to time we make a correction called leap second. Leap second should not be confused with leap year. It has no relation with leap year. Leap year occurs because Earth ka jo revolution hai, that is about 365 days, 0.25 days, and every 4 years we make this correction of 1 day. That is a separate concept. So leap second ka concept hai, that emerges because of Earth's rotation on its axis. If Earth's rotation has fastened or slowed down a lot, then from time to time in timekeeping we will add or subtract a leap second, and all of this is done by an organization called International Earth Rotation and Reference System Service, an independent organization which basically measures Earth's rotation. There is another phenomena called Chandler wobble. In one line you just have to remember that the Earth ka axis of spin hai, that also is not fixed. It actually in itself changes. Such type of motion is called precessional motion. You can imagine it like a top, that top which rotates on its axis. When top rotates on its axis, then this axis is also not fixed. This axis also changes. This axis in itself rotates. So such type of motion is called precessional motion, where the axis of rotation is also not fixed, in itself is changing. So when we assume Earth to be rotating on a fixed axis, so for example, when I am saying that ye jo axis hai, this axis is Earth rotational axis and Earth is rotating on this axis. So if I am assuming that Earth's rotational axis is fixed, that is not the correct assumption, because turns out that even this rotational axis changes a little bit, and that change is called Chandler wobble, after a scientist named Chandler who first discovered it. So if I have to remember, I will just remember one line about this. Carlo Chandler discovered that how spin of Earth as it rotates on its axis, that in itself changes as time passes. Yes, it does. Angle of inclination jo hai, that is, we assume it to be 23.5 degree, but that is not exactly 23.5 degree. It actually changes from about 21 to 24 degree. 23.5 is just the average. Right now axis is about, but however this change is very slow. So in our day-to-day life that does not affect a lot, but into hundreds of years we can actually monitor that change. So even though this change occurs, this change is happening really slow. One more important concept, I am not very sure if why it has not been covered into this material, perhaps it will be covered into updated material, is a recent discovery that Earth ka jo inner core hai, that is actually slowing down as of now. So there was a very famous discovery done by some scientists in China. We have not a lot of idea about Earth's internal structure, simply because Earth ka jo radius hai, pura diameter is 64 and one radius is 6400 kilometer, and even crust, forget core going to core, we haven't actually dug a depth which goes beyond crust. So whatever we know about Earth's internal structure, that is because of indirect evidences. So recently there was a news, but that news was frankly very misleading. That news told something like that Earth ka jo inner core hai, that it's slowing down and reversing its direction. It looked like a dangerous thing, that some danger is happening, but frankly that was a very misleading headline. So what is happening is that because Earth is not one solid object, Earth has many layers. You have crust made of rocks, you have mantle, then you have core which can be further divided into two parts, and inner core and outer core. So outer core hai, that is liquid, so inner core hai, that is solid. Now because inner core in itself is a solid around a liquid, it has its own motion. So inner core ka jo rotation hai, that is little bit faster generally than rotation of Earth. Little bit, very little, 1 degree faster than rotation of Earth. But from time to time, inner core also slows down. Scientists have found out, although there is a theory that it happens in about 70 years, but इसका आज सच कोई साइंटिफिक एविडेंस नहीं है एंड बहुत ज़्यादा इसका डेटा भी नहीं है विच कैन एक्चुअली पिन पॉइंट. So from time to time what happens is that because of outer core which has lot of charges moving around it, which produces lot of magnetic field, so there is an interplay between gravitational force and magnetic force, and that interplay leads to sometime inner core slowing down, sometime fasting up. So as of now recent studies have shown that जो inner core of earth है, a solid inner core, that is slowing down. So slowing down compared to earth's rotation. So because it is lagging behind earth's rotation, some scientists or some headlines called it that it is stopping and reversing its direction. That is not what is happening. All what is happening is that generally it moves faster compared to earth's rotation, but recent studies have shown that it is moving little bit slower. It is slowing down and it may actually lag earth's rotation, and the only way we have all of this data is with study of earthquake waves. So जो earthquake waves है, they are the most important source to know about inner structure of earth. This is a topic I think to be very important. हाँ, ये भी एक न्यूज़ है कि even inside inner core there may be a smaller core, and some scientists are think that that is a possibility, but that news has to, what he's saying is that there has been a recent news that even inside inner core there are not actually two core, cannot be divided into two but three parts, and even inside inner core there is another smaller area distinct from the inner core, and that is again because of study of earthquake waves, but it requires more data. We need to confirm that with the help of more and more data. Exactly, I do remember that. I do remember reading that some scientists are claiming that there may be some other core inside the inner core itself, but it requires more data to confirm it. This is a very important topic. Double asteroid redirection test, or simply DART mission. Here you have to know 2-3 things. First is it is a mission of NASA. This is a mission to check our planetary defense against an asteroid attack. That if there is an asteroid coming towards Earth, if a very heavy asteroid comes towards Earth and falls on Earth with very high speed, it is going to cause an earthquake of the Richter scale of perhaps 12, 13, 14, 15, which will lead to a mass level extinction. The entire Earth, entire all organisms can become extinct. Not a theoretical thing, already has happened in the past about 65 million years ago when dinosaurs became extinct because of such asteroid impact. Now as far as we know, whatever data we have, for next few hundred years, about 100 to 100 years, we are not going to face any asteroid threat. Again, this is based on our current level of knowledge. Maybe tomorrow we will find some other data and this knowledge is going to change. But as far as we know, there is no asteroid coming towards Earth which is going to cause a damage. There may be objects moving around Earth, but not exactly coming towards Earth for a head-on collision. Same is also true for this asteroid system. So this actually is two asteroids. There is a larger asteroid called Didymos, which is being revolved by another smaller asteroid called Dimorphos. So there is an asteroid system, one larger asteroid, another smaller asteroid moving around it. So NASA का जो mission था, that was just to check that if we can change the orbit of this smaller orbit. That there was a DART mission जो है, that basically was a very heavy object, imagine it a solid object, going to travel and colliding with very high speed with an objective that let's change its orbit. Now NASA as of now is collecting data that how much this orbit has changed compared to the past. आप इसको इस तरीके से imagine कर लो that changing somebody is coming towards you with very high speed and आपने बस उसको धकेल दिया, उसी के momentum को use करके आपने उसको धकेल दिया. Or for example how batsman can use a very fast bowler, that a fast ball, very fast ball and a small perhaps flick into a direction and it goes for a 6. So the goal here is that we can perhaps push it with a weapon, with this mission by the way, not a weapon frankly, push it with a kinetic energy so that it changes its orbit. This was the first demonstration. NASA plans to do more demonstrations like that in future, because if there is an asteroid attack in the future, we want to prepare ourselves, a planetary defense mechanism. As far as we know, there is no asteroid coming towards Earth in next 100 years, 200 years, but just in case we want to prepare ourselves that if there is any threat, we are going to be prepared for it. So in this topic, you have to know few things. First, DART mission is a mission of NASA. Second, the goal of DART mission was to change the orbit of a smaller asteroid, which was orbiting a larger asteroid, by a kinetic impact. Third, this asteroid was not coming towards Earth. It was never coming towards Earth. That was just to demonstrate that if it is a possibility or not. And NASA as of now is collecting more and more data that what this collision has actually led to. So I do think this to be an important topic for prelims examination. Sophia mission, in one line, a joint mission of NASA and German Space Agency, a telescope which, by the way, for the first time found that there is water on moon. Chandrayaan 1 also discovered it, but Sophia mission also found this presence of water on the moon. I don't think this to be very important. In one line, Sophia, a telescope of NASA and Germany, that's it. Now, hybrid propulsion system is actually quite an interesting topic. I told you in the last class that the rocket fuels, and they can be solid or liquid. And I told you that both of these fuels have their own set of advantages and disadvantages. Solid fuels, once it starts burning, you cannot actually control that burning. But here is the thing, that fuel burn in the presence of oxidizer. In petrol, diesel, car, जो हम normal engine use करते हैं, there is already oxygen in the atmosphere. We do not have to carry oxygen with us. But for space vehicles, for launch vehicles, for rockets, we do have to carry oxygen. So what ISRO is trying to do, that let's use a solid fuel, but let's use a liquid oxidizer. So solid fuel requires still oxidizer to burn, but liquid oxidizer का फायदा क्या होगा? That we can control the flow of oxygen, we can control the flow of oxidizer, and based on that, if we want, we can change the thrust. If we want, we can restart our engine, even with the help of solid fuel. So generally solid fuel का जो सबसे बड़ा disadvantage ये होता है, easier क्यों है? Solid fuel is cheaper, it is simpler, safer, बहुत सारे benefits है. But disadvantage क्या है? That you cannot control the thrust. You cannot switch off your engine, you cannot restart your engine once the engine starts. But with the help of still solid fuel but liquid oxidizer, let's assume it to be a semi-cryogenic oxidizer, perhaps liquid oxygen, now we can even maintain our thrust and we can restart our engine. This is what ISRO is working upon right now, and maybe one of the rockets of future will have this capability, that a solid fuel and a liquid oxidizer. So LVM-3, which is going to be used for Gaganyaan mission, I told you in the last class LVM-3. So LVM-3 requires this booster. These boosters are called HS-200. जो side में आपने दो बड़े boosters देखे थे, they are called HS-200, powered by solid fuel. So this was checked by ISRO, that's it. So in one line, HS-200 is a solid booster which is being used for GSLV-MK3 or LVM-3 strap-ons, yes, but not similar to strap-ons of PSLV. Inflatable aerodynamic deflator, this will become clear with the help of a picture. अगर आपको याद हो, Chandrayaan 2 mission had a orbiter, a lander and a rover also, but orbiter is still operational, it is still collecting data, but lander and rover जो है, lander has to separate, it has to fall towards moon. But anything which is falling towards surface of a planet, or in this case moon, it is going to accelerate. So it is going to fall with very high speed. So you have to basically reduce that speed. Otherwise it can crash and आपका जो पूरा mission है वो fail हो जाएगा. Exactly this is what happened in case of Chandrayaan 2, that जो lander and rover है, we were not able to reduce its speed on the right time. Because of that it fell with very high speed and it crashed. So this is called soft landing, that you are trying to ensure that it lands with very, very less speed, hopefully speed very close to zero. So when that happens, it lands softly and still your जो भी आपका lander rover है, it is going to collect data, it will remain operational. So as of now ISRO is working, and it has already, by the way, demonstrated that a double safe mechanism, that first we will try to reduce the speed, वो तो हम करेंगे ही करेंगे, but apart from that, this mission will also have this what we call aerodynamic deflator. Sorry, inflatable aerodynamic decelerator. That you'll have a mechanism into packed condition part of your mission, any mission, perhaps Martian mission, lunar mission or Venus mission, jo bhi mission ho, that if it is specially going on the surface of a particular planet or surface of moon, then this inflatable aerodynamic decelerator will be part of that. We will give one more command apart from first, so the double safe mechanism, we will try to reduce its speed, but it will also have a mechanism so that this in proper condition, when it is properly deployed, it is going to create a structure like this. So first, this is now at the bottom, आपका जो भी probe है, even if it is falling with very high speed, it is falling on this object here, and this has very soft surface, there are gases inside it, and because of that जो आपका भी mission है, that will undergo soft landing. So even if, and by the way again a double safe mechanism, we will first try to reduce the speed, and along with that we will also deploy this. So best solution तो ये होगा कि दोनों काम करें, but even if one does not work, this should work and your mission should become successful. So ISRO is going to use it perhaps for Chandrayaan 3. By the way, Chandrayaan 3 ISRO is planning as of now, as we speak, perhaps this year or perhaps by next year. So Chandrayaan 3 may have this, what we call decelerator, inflatable aerodynamic decelerator. Rohini. It is possible. So I told you, did I talk about reusable rockets? So in reusable rockets also, in general, some perhaps if you want to recover a part of component of rocket, then as it splashes down even into ocean, it splashes down with very high speed, and we can deploy it perhaps to recover a part of rocket. That is the goal here, but I'm not very sure how much applicable that will be, because ideally when we talk about recovering rocket, then ideally rocket should carry its own fuel for its return journey. What Elon SpaceX का जो पूरा rocket है Falcon, जो what it achieves. A very किसका फर्स्ट स्टेज है, फर्स्ट स्टेज हम फर्स्ट स्टेज रिकवर करेंगे. कोई भी जो रॉकेट है, फर्स्ट स्टेज इज ऑफन द लार्जेस्ट वन, एंड हम फर्स्ट स्टेज को हमेशा रिकवर करने की कोशिश करेंगे, इंक्लूडिंग फाल्कन. फाल्कन का भी जो फर्स्ट स्टेज है, दैट इज गोइंग टू बी रिकवरेबल. A very famous rocket ISRO made many years ago called Rohini rocket. These are called sounding rockets. Sounding rockets simply mean that they do not actually go and complete an orbit around Earth. They go at very high altitude, collect some data about higher altitude, and come back. So ISRO has launched many such rockets. Recently it did the same thing, a two-stage rocket capable of climbing to a height of 70 kilometers. It will collect some data from the upper part of atmosphere and will come back. So these rockets are called sounding rocket, and sounding rocket of ISRO जो नाम है, we call it Rohini. I was talking about remote sensing or Earth observation satellites in the previous class. A very famous remote sensing satellite called RISAT-2. Nobody on government's website you will find that this is a spy satellite, but it was a spy satellite. It was launched initially 13-14 years ago. The original plan of ISRO was only to have for 4-5 years, but because of effective, efficient uses of battery, this was extended to about 12-13-14 years. So recently this was in news because it made uncontrolled entry into atmosphere and it fell into Indian Ocean around Indonesia. So lot of it burned down, but some part fell down in the Indian Ocean region. It may have occurred, we do not know frankly why it may have occurred, because ISRO hasn't divulged any data except the fact that it has happened. But why has it happened, that it has not divulged. But if it is, for example, not an if not, it is not espionage, and we have to assume that it is not espionage because 13 saal ho gaye the. So maybe it had no fuel, that its orbit changed a lot, and after a point of time it was impossible to course correct its original orbit, and because of that it fell down towards Earth. So this topic was in news simply because an Earth observation satellite of ISRO, launched in 2009 by the way, 13 years ago, it made a re-entry into atmosphere and fell down into Indian Ocean near Indonesia. And if you go and search about it, by the way, it is written here also, border surveillance satellite, but you will not find this on ISRO's website. ISRO website mentions that it is in general an Earth observation satellite. I was talking about Aditya mission. I told you that very similar to L2 point where Webb telescope has been kept, a telescope, we can have a very good solar observatory at L1 point. So this L1 point is called Lagrangian point 1, and जो आदित्य मिशन का गोल ये है कि जो सन के आउटर मोस्ट लेयर्स हैं, photosphere, chromosphere and corona, let's collect more data about them, and using that data it is going to be, by the way, very useful to understand coronal mass ejection or solar flares, etc. Did we talk about this meaning of these terms? Coronal mass ejection or solar flares. So there are three terms which are often used, but by the way, all three of them are different from each other. First is solar wind, second is solar flare, third is coronal mass ejection. Now, sun के बहुत सारे layers हैं, very similar to layers of earth. Even sun has many layers. For example, at the core of sun you have core where nuclear fusion happens. There are many other zones like convection zone, radiation zone, but the outermost layer which we can see, this is called photosphere. Now while the core temperature will be about 10 to 15 million degrees Celsius, the photosphere average temperature will be about 6000 degree Celsius. So temperature high or low is always a relative term. The 6000 is of course very high temperature for us, but compared to the core of sun, this is a very low temperature. Around photosphere there is a thin layer around sun. This layer is called chromosphere. Not visible because its temperature is less than photosphere, and it is very thin also. So it is not visible with our naked eyes, but with very powerful telescopes it can be witnessed. And beyond chromosphere, you have this layer which is called corona. And corona is a very interesting layer because यहाँ पे temperature again becomes 1 to 1.5 million degrees Celsius. Corona extends millions of kilometers into the sky compared to sun outermost layer of photosphere and chromosphere. Corona is also not visible because even though the temperature is very high, it is a very scanty region. Particle density यहाँ पे बहुत कम है. Corona आपको सिर्फ और सिर्फ दिखेगा during total solar eclipse. If you look at the total solar eclipse picture, you will find that entire sun is shadow, but there are shimmers of light around, all around the sun. It's a shimmer of light which you see, that is what solar corona is. Sorry? Chromosphere का less than photosphere है, less than photosphere है. Something like this. If you look at the total solar eclipse picture, you will have the entire sun blocked by moon, but beyond this you are going to find this shimmer of light. And we know the size of sun is very huge. Now compared to this size, you can assume the size of corona also, that up to how many kilometers it extends into the sky. The solar corona hai, that is a very interesting reason. Very interesting phenomena is that its temperature is very high, and we have very good theories, but frankly they are not very, बहुत सारा acceptability नहीं है. So we still are trying to understand that why coronal temperature goes up to 1.5 million degrees Celsius into certain cases, and why this understanding is important, because not everything which comes out of this sun is useful for us. We all know about ultraviolet light. That ultraviolet light is filtered out by ozone layer, thankfully. But apart from that, there are many more things which actually emanate from sun. And we often can categorize this into three parts. And all these three parts are actually used interchangeably, but they all mean three different things. First is called solar wind. Second is called solar flare, and third is called coronal mass ejection. जो सोलर विंड है वो रेगुलर एक्टिविटी है, दैट फ्रॉम टाइम टू टाइम सन emanates lot of charged particles, high energy photons also. Regularly it keeps on doing that. That is called solar wind. Lot of charged particles are continuously being emanated from sun. These charged particles do travel throughout the solar system. Some of them can come to earth also, but that is a regular phenomena. They have high energy but not that high energy. So solar flare and coronal mass ejection hai, they are often used interchangeably because both of them often occur simultaneously and both of them can have impact on earth. But nonetheless, these are two different things. When we talk about the term solar flare, then we are talking about high energetic photon. We are talking about light of very high frequency. We are talking about X-ray, ultraviolet light of very high frequency. This very high frequency light, of course, because it is light, it is going to travel with speed of light. It will come to Earth's atmosphere in about 8.3 minutes. And it can give lot of energy to our atmospheric particle, which can have its own impact. But when I talk about coronal mass ejection, that often occurs simultaneously. This coronal mass ejection is that a part of sun, we are talking about not light now, we are talking about matter. We are talking about electrons, protons, we are talking about hydrogen ions, helium ions. They are ejected with very, very high energy. And as they are ejected, they travel through the entire solar system, including Earth. Now compared to solar wind, they are much more powerful, they are much more intense, and they can actually cause damage on Earth. What type of damage? So the good thing is that Earth has its own magnetic field, and because of that it is going to repel lot of these particles. But some particles, by the way, can enter from the polar areas, which leads to formation of what we call auroras. So auroras occur because of interaction of solar particle with Earth's atmospheric particle. Beautiful production of light in the sky. As long as it is that, it's beautiful. Tourist spots हैं, लोग जाते हैं polar areas में aurora देखने के लिए. But if the solar flare has even more intensity, their energy is very high. So first thing will happen is that aurora can be witnessable even in higher latitudes. For example, now in almost all of Europe, just 2-3 days ago, people witnessed aurora because the solar flare had actually very high intensity. What generally is witnessed into North Pole or South Pole, people of Europe witnessed it. But if it even has more intensity, then it can fry up the circuitry of our satellite. जो GPS satellites हैं, जो communication satellites हैं, they can stop working. And even if it has more intensity, then it can actually enter into Earth's atmosphere. It can lead to a surge of electricity into our power transmission line, and our power transmission lines are not made for very high surge. There is going to be blackout, and that blackout can be very dangerous because we are very much dependent upon technology as we speak. So they will not cause direct damage to us, but they will have this indirect damage, that lot of our infrastructure, power infrastructure especially, that is going to be damaged. तो ये जो solar activity है, the impact of solar activity around Earth, such as auroras or such as in general flow of this charged magnetized particles around Earth, that is called geomagnetic storm. So we use a word here. Geo means Earth. Around Earth you have a magnetic storm. That magnetic storm is happening because of this very charged and highly magnetized particles traveling around Earth with very, very high speed. And that can have lot of changes into Earth's outer atmosphere. If enter into lower atmosphere, if they have very high energy, then they can cause global blackouts also. So it is only fortune that because sun is really huge, this type of event can occur any part of the sun, and it can, a directed energy beam can go anywhere in the sky. But if it is unfortunate for us, if we are unfortunate, then Earth can, if Earth is in that line of sight, then all of this intensity can come on Earth, can be directed towards Earth. So it is only our luck that often this type of very high intense solar flare misses us. And it is not just luck, frankly, it is also a matter of probability, because sun is really huge and compared to sun, Earth is very, very small. If this entire room is sun, then Earth is perhaps the tip of this pen. So in that sense, solar flare can occur anywhere, and often Earth will be saved by solar flare. But in future, maybe it will not be. So understanding of solar flare, how powerful they are, all of that is very important. How corona, and by the way, jo event hai, this occurs because of this coronal mass ejection. Now why this happens, why corona has high temperature, all of that data will be collected by Aditya L1 mission, right? So Aditya L1 mission hai, that is going to be the first solar observatory of ISRO, where we are planning to launch this observatory in halo orbit around Lagrangian point L1, and at Lagrangian point 1, the required centripetal force will come from the combined gravitational effect of both sun and earth. इतनी सारी चीजें हमारी clear होनी चाहिए for prelims or even for mains examination, because it is a mission of ISRO. So ये mains में भी UPSC आराम से पूछ सकती है. Yes. हाँ, we can say that, yes. Earth's magnetic field is because of outer core actually, not inner core. So outer core is liquid, lot of charged particles are moving around with very high speed, and charged particles moving with very high speed will produce magnetic field. So Earth's magnetism जो है, that is because of activity, charged particles moving into core area. हाँ बिल्कुल. तो impact of solar particles, impact of these charged magnetized particles around Earth, collectively we can call it geomagnetic storm. But geomagnetic storm can lead to lot of things. It can lead to auroras, it can lead to satellites not working well, it can lead to power disruption on Earth. So it can lead to lot of things depending upon how powerful it is. Imagine it like normal wind versus a very powerful storm or a cyclonic wind. So solar wind जो है, that is like normal wind, that it always happens, no problem with that. From time to time the intensity can increase. Imagine that like a storm, right? So you have to stay inside your house, but from time to time it can be a cyclonic wind. So forget staying inside house, you have to leave the house and take a shelter someplace. So imagine a very powerful coronal mass ejection like that, that it can now cause damages on Earth, not just in the upper atmosphere, not just satellite, but on Earth. ठीक है? Any question in this topic? So आदित्य L1 मिशन का जो बहुत important objective ये है कि sun के outer most layer को observe करना, not just into visible light, but into ultraviolet also, into X-ray also, into infrared light also, and measure why coronal temperature is so high. Also measure the solar particles as they travel from sun to the solar system. What is their magnetic field? What path do they take? All of those things it is trying to measure with the help of, it has about 7 payloads, not about, exactly 7 payloads. Yes. Not polar vortex. So it is that is also a type of coronal mass ejection. So the news he is talking about, that there was a news that a part, by the way, that actually caused the geomagnetic storm which you were witnessing just 2-3 days back, that a part of sun broke away. So why it can happen, let me explain that with the help of another concept which is given in your material. By the way, geomagnetic storm में दे ही रखा है. जो concept of geomagnetic storm है, ये भी दे ही रखा है आपके material में, which occurs because of coronal mass ejection. Often these solar flares and coronal mass ejection are used interchangeably because they occur from almost same reason, even though they are two different things. जैसे last year UPSC का जो question था, they actually asked the impact of solar flare on Earth, but ideally it is actually impact of coronal mass ejection. However, for all practical purposes, we can use these two words interchangeably, even though there is a technical difference. So what happens is that there are two other things which you should know about sun. First is called sunspot, second is called coronal hole. Not exactly same thing again, but very much related to each other. Now what happens is that you will find some regions on sun where the temperature is less, on the surface of the sun. You will find on the surface, on the photosphere, where temperature is less than the surrounding region. So if you look at that with the help of infrared light, you are going to find that this part will emerge darker compared to other part. So ये जो regions of sun है which are darker compared to the other part, in infrared light we call them sunspot. Now sunspots जो हैं, they have lower temperature. Now lower compared to the surrounding. If surrounding is 6000, here temperature is about 3000, 4000. Now still that is very high for us, but compared to the surrounding it is less. Now why the temperature is less here? Because here magnetic field is very powerful. Magnetic field does not allow lot of heat energy to be released back to the surface. It's like the magnetic field has created a very tight grip around this region. Imagine a rubber being squeezed tightly, but the moment you release this rubber is going to regain its original shape. So lot of energy is built up here, and lot of this built up energy from time to time, what will happen, where magnetic field will not be powerful enough, then it is going to realign itself, and that will lead to expulsion of lot of particles which we can call solar flare or coronal mass ejection. So ये जो region of sun है, these are called sunspot. They are temporary, they emerge randomly, they grow into area, and they again go back. Their area decreases, they go back. This happens in a cycle of about 11 years. That after every 11 years, you will have sunspot activity that will reach to a maximum. Again, it will go to a minimum. And जहाँ पे भी sunspot activity बहुत ज़्यादा होगा, वहाँ पे coronal mass ejection भी सबसे ज़्यादा होगा. And almost simultaneously another thing which is witnessed, that around the region of sunspot, जो corona area है, not the photosphere, but in the corona you are going to find that जो magnetic field है, that has completely broken away. So if you look at this with the help of X-ray, you are going to find a darker region. So such regions are called coronal hole. But coronal hole is found not on photosphere, it is found in the corona area of sun. But sunspots and coronal hole, they occur almost simultaneously. They happen almost simultaneously. And wherever coronal hole is happening, it means that sun does not have a significant part of this particle has actually moved away from sun. So जो NASA का जो अभी एक जो news था, that a part of sun has broken away, that was also something like coronal mass ejection. The only difference was that this was one of the largest solar particle being removed from sun, which was witnessed by NASA. So that's why it was a news. It is not unusual. What was unusual was the level of this ejection, right? The photosphere पे जो sunspot से photosphere पे दिखेगा, जो sun का जो outermost surface है, not corona. Corona is even, corona जो है sun का, I can assume corona has to be the atmosphere. जो sunspots हैं, they will be witnessed on the photosphere. जो coronal hole है, that will happen into the coronal region. जो magnetic field of corona है, there will be a significant gap here and there, and because of that they will be relatively cooler compared to the other coronal area, but coronal hole emerges into solar corona. So in any case, sunspots, coronal hole, two different things, but nonetheless they happen almost simultaneously, and often, and because of that both coronal hole also happens into this cyclical phase of 11 year. So this cyclical phase of 11 year is called solar cycle, and we have witnessed many solar cycles till now. It may have been happening for millions or for billions of years as we know, but at least 23-24 solar cycles we have witnessed that solar sunspot activity is going to a maximum, again going to a minimum. Two, three things. Sunspot occurs on the photosphere, coronal hole happens in the corona. सबसे पहला तो यही difference है कि where it is happening. Second thing, sunspots means a cooler area on the photosphere. Coronal holes mean that part of magnetic field in the corona is broken. Because of that, lot of particles can emanate from these areas and they can spread throughout the solar system. So जो coronal holes है, that will actually lead to lot of solar flare and coronal mass ejection, right? Sorry? Neutrinos are entirely different thing. Neutrinos can be produced as part of, they can be part of solar storm or in general solar activity, but neutrinos are much more than that. We will talk about neutrinos, I am very sure, in if not this material then updated material. Yes. We can say that, yes. So wherever sunspot activity will be very high, the solar flare activity is also going to increase. Yes, there is a direct correlation between these two. So yes, that is actually correct. Space Tech Innovation Network. ISRO has signed an MOU with a company called Social Alpha, and they have established what we call Space Tech Innovation Network. The goal here is that जो भी young innovators होंगे, startups होंगे जिनको support की ज़रूरत है in terms of capital, in terms of technology, then with the help of this initiative they will be supported. Simple, in one line. It will help young startups, young innovators into space research. Solar eclipse is the next topic. Solar eclipse occurs when moon comes between sun and earth. The reason why moon can completely overshadow sun is very simple, because even though moon is very small, but it is also very closer to earth. So in sky, both of them look of the same size. If you think about it, जो moon का size है, जो sun का size है, हमको same दिखता है. Even though we know it for a fact that sun is very very huge. Moon तो earth के मुकाबले भी बहुत छोटा है, तो sun के मुकाबले तो बहुत ही छोटा है. But because it is also very closer to earth, whenever it comes and sun, it can cause a complete shadow, and that can lead to a solar eclipse. Opposite that, when earth comes between sun and moon, it can lead to lunar eclipse. Now there are few things which you should know about solar eclipse. First thing, it does not happen very quite often. If you have ever witnessed a total solar eclipse to one area, then there is a very good chance that in your lifetime you will not find another total eclipse. You will find partial eclipse, but not total eclipse. Now what is the difference between total eclipse and partial eclipse? ये मैं बता देता हूँ, but उससे पहले why solar eclipse does not actually happen more often, and there is a very good reason for it, and that reason is that if, let's say for example, my hand represents the orbital plane of earth, imagine that this is the orbital plane of earth, तो जो moon का orbit around earth है, that is little bit inclined. So imagine this pen which has an angle of about 5 degree with this plane, and moon revolves around earth like this. तो जो earth sun orbital plane है and जो earth moon orbital plane है, they are not exactly into the same plane. अगर ये सेम प्लेन में होते तो सोलर इक्लिप्स आपको हर साल में एक दो दिखता, वेरी सिमिलर टू हाउ वी सी लूनर इक्लिप्स. बट सोलर इक्लिप्स इज वेरी रेयर, बिकॉज इवन इफ लेट्स से फॉर एग्जांपल मून डज कम, बट इट इज हियर, मून इज between earth and sun, but it is in one of the its ascending node, above it or below it, it cannot actually cause any type of shadow between earth and sun. So that is why solar eclipse, especially जो total solar eclipse है, that is a very rare phenomenon. Second thing, whenever we talk about eclipse, eclipse occurs because of shadow, but I can have two types of shadow. One shadow is called umbra, another shadow is called penumbra. In this picture, that moon is blocking sunlight, but there will be a very small reason, by the way ये तो inclination के कारण है, there will be a very small reason if you are on earth, in a very small region, in a very small region of earth, moon has completely blocked the sun. Because of that, you are going to find a total solar eclipse. This is called umbra shadow. But then there will be another reasons also, for example, especially in this region, that partially, there will be partial blockage of sunlight. Another type of shadow which is called penumbra shadow. If you are into any penumbral region, you are going to witness a partial solar eclipse. So partial solar eclipse occurs into a much larger area, and that is why it can be witnessed more frequently compared to what we call total solar eclipse. Now total solar eclipse can further be divided into two parts. In fact, let's call it two separate eclipses, total and annular. Now what that happens, when that happens, every orbit is elliptical. सबसे पहले तो ये क्लियर होना चाहिए that मून का जो ऑर्बिट है वो भी वैसे तो काफी ज्यादा सर्कल के क्लोज है, बट है तो फिर भी थोड़ा बहुत इलिप्टिकली. Because of that, there will be a reason where moon will be very closer and moon will be very farther away from earth. So if it is closer to earth and comes and blocks sun, then it can completely block the sun if it is closer from earth. That will lead to a total solar eclipse. But if it is farther from earth, then it will not be able to completely block, it will able to perhaps block this entire region, but ये जो region है वो फिर भी आपको दिखेगा. An annular region, annular क्या होता है? Two concentric circle के बीच का जो place है उसको हम annular region बोलते हैं. So you are going to find what we call annular solar eclipse. That happens when moon is very far away from earth and then blocking sun. If moon is very closer to earth and then blocking sun, that will lead to total eclipse. And if very far away from earth and then blocking sun, that can lead to annular eclipse. But there is another very rare phenomena. In certain places, even if it is a total eclipse, because earth has its own curvature, and if moon has not completely shadowed, some people are going to first find the annular eclipse, but as earth and moon are perfectly aligned, then they are going to find a total eclipse. That is a very rare phenomena, but it is possible that you are going to find both annular and total eclipse from a same region. That is actually called hybrid total solar eclipse. हाँ, कोरोना जो है हम दोनों में दिख जाएगा. जो कोरोना है, by the way, it is never advisable to look at the solar eclipse with naked eyes, but if you have protective gear watching it indirectly, then of course you can see it. So yes, कोरोना जो है आपको दोनों में दिख जाएगा, because कोरोना जो shimmer of light है, as sun's most of the light is blocked, अब ये जो shimmer of light है, that is going to be visible. This concept of blood moon, that is type of lunar eclipse, but in this lunar eclipse, earth का जो umbra shadow है, so again earth can also have two type of shadow on moon, umbra or penumbra. If moon is in the umbra shadow, moon is going to be completely blocked by earth. And in some places, for example, we do find this red light scattered into the sky, and because of that we call it red moon. But fundamentally it is a complete lunar eclipse where moon has completely been shadowed by earth, because earth is between sun and moon. Two things here: fast radio burst and gamma ray burst. So as the name suggests, this is radio wave, this is gamma ray. Both are type of electromagnetic wave, but their energy is going to be very different. Radio waves have very less energy, gamma rays have very high energy. So astronomers have, from time to time, they have recorded fast radio burst from some distant sources in the sky, but we still do not know what are those sources. But from time to time we have witnessed, there are many theories. Maybe it is happening because of perhaps some black hole feeding on a star, maybe it is because of a neutron star. There are many theories, but still there is not any accepted theory that what are the sources of. And by the way, they are called fast because they only exist for matter of few seconds and then they are gone. So from time to time astronomers have observed this fast radio burst emanating, but we do not know the source. But जो gamma ray burst है, for that we have a very good theory that gamma ray bursts, they are maybe happening because you have merger of perhaps neutron star, or neutron stars are colliding with a black hole. So apart from gravitational wave, so gravitational wave के लिए तो आपको एक अलग detector चाहिए, LIGO, something like LIGO, but you can also detect, because of this merger, you do find this fast burst of gamma rays. So they are called gamma ray burst, and gamma ray burst can occur because of merging of a neutron star into a black hole, something like that. And here we have still some idea that what can be the sources of gamma rays. But जो radio burst है, for them we do not know what are the sources. This too I already have told you. Betelgeuse and white dwarfs. Saturn के अराउंड बहुत सारे रिंग्स हैं, not one but Saturn के अराउंड बहुत सारे रिंग्स हैं. And recently some scientists are hypothesizing that this ring creation may have actually occurred because of one of the moon of Saturn called Chrysalis, but again that is only a theory. I don't think that is important. But you should know that Saturn has not one but many ring systems around it. But Saturn is not the only planet. Other planets also have ring. For example, Jupiter, Neptune, and Uranus also has ring. But their ring system is frankly much more restricted. Jupiter ke around only one ring system cannot be in fact witnessed with lighter telescope. You require very powerful telescope to witness the. I'm not very sure, frankly. I'm not very sure. But ऐसा dust तो नहीं होगा. IC मतलब particles तो होंगे, IC particles ही होंगे. Especially I'm talking about very far away from solar system. So I'm very sure that वो भी IC particles ही होंगे rather than calling it dust particle. But I will have to confirm it. So I think that it should be IC particle because we are talking about very far away from solar system. Moon ke soil ko when Neil Armstrong and Buzz Aldrin they came back to Earth, they collected a lot of sample. There have been other sample collection from Moon, despite not unmanned mission. There have been some other sample collection mission from Moon, and with the help of the lunar soil, scientists have been able to develop plants. Now that is especially quite important because if you ever colonize Moon, then such type of scientific understanding that how we can use it for plant can be very useful. So a very small news, I don't think it is important for prelims examination frankly, but using lunar soil, scientists have been able to grow a plant. New asteroid called AP7 was discovered. I don't think this is very important news. If in one line I have to remember, this object AP7 is an asteroid, that's it. Sorry? अच्छा डस्ट की है ओके जो exoplanets हैं scientists have detected some material into an exoplanet called WASP with the help of in fact Webb telescope. So exoplanet I already have told you that any planet which is not part of solar system they are called exoplanet. So जो WASP 76b है और WASP 121b है, they are example of exoplanet. And then there is a very famous comet, one of the largest comet in fact which had been witnessed, this Bernardinelli-Bernstein comet. So that is one of the largest comet, and comet का जो origin है, there is a very famous theory that in far regions of solar system there is a type of cloud which is called Oort cloud, but nobody has actually witnessed Oort cloud. That is only a theoretical construct as of now. But comets, we do know that they have this shiny tail and they often orbit around solar system into a very elongated orbit around sun itself. There is a concept of dark sky reserve because this has happened. A reserve into India has been mentioned. Because of that, this topic becomes important. So dark sky reserve simply means that if you are monitoring, if you are collecting astronomical data, then there is no presence of artificial light, because the artificial light that can actually adversely affect your astronomical data, especially if you are collecting data from a telescope on Earth. So you do not want other light sources. And light pollution basically is this excess presence of light can have many problems, by the way, but one of that problem can be in astronomy, that how it can affect astronomical observation. So there is an organization called International Dark Sky Association which basically designates certain places as dark sky reserve. Now why this is important? Because if you are a stargazer, if you have a lot of interest in astronomy, then you can go to such places. So it has not only astronomical significance but also significance for tourism. That this wildlife sanctuary into Ladakh, Changthang Wildlife Sanctuary in Ladakh, it has become India's first dark sky reserve. What it means is that astronomers के लिए एक बहुत ही बढ़िया place है, that you can collect data about distant objects into sky without bothering, without being worried a lot about presence of artificial light. So this becomes an important topic because of this has happened into India. So if I have to remember in two things, this sanctuary automatically comes into news, so that if there is a question about this sanctuary, then that will be a question of environment inspired from current affairs. So the Changthang Wildlife Sanctuary, that is in Ladakh, first, and second thing I will remember that it has become the first dark sky reserve of India, which is denoted by this organization, International Dark Sky Association. And what do you mean by dark sky reserve? It simply means that it is a very good place for astronomers because your astronomical observation is not affected by artificial light. Indian Astronomical Observatory already has few telescopes around Ladakh. So Ladakh is a very suitable place for telescopes, along with another very famous place in Uttarakhand called Devasthal. So you have telescopes at Devasthal in Uttarakhand, or you have telescopes at Ladakh, because they are at very high altitude, and at high altitude atmosphere is very thin. Now why this thin atmosphere is important? Because जो atmosphere है बहुत सारे light को filter out कर देता है. So a lot of light coming from distant sources, distant stars and galaxies, they would have entered on Earth, but thanks to atmosphere filters out a lot of things. So if you have to actually monitor stars and galaxies, you have to go into space. That is why many telescopes are placed into space. But certain type of light can actually cross atmosphere, such as radio wave. So radio wave जो atmosphere को भी cross कर सकता है. So often you will find that many radio telescopes, they are placed on Earth, while telescopes which are observing universe into visible light or infrared light or ultraviolet light, they are often placed into space, such as Webb telescope or Hubble telescope. But जो radio telescopes हैं, most of the time they will be placed on Earth itself. But there can be some suitable places on Earth that even other type of light, such as infrared perhaps or microwave, can be recorded here. And two places in India are very famous places, in Ladakh basically and in Devasthal, Uttarakhand. One more, another very famous telescope called Sampurnanand Optical Telescope. This is in Nainital, Uttarakhand, and it has completed 50 years of operation. There is a telescope called Saras telescope, shaped antenna measurement of background radio spectrum. That was in news because it actually found some signal from distant galaxies. So there is a telescope. So I have to know two things here. Saras 3 is a telescope. सबसे पहली चीज तो यही पता होनी चाहिए. Designed by Department of Science and Technology, and it is situated in this around very famous lake called Dandiganhalli Lake in Karnataka. So if I have to remember, I will remember 2-3 things here. That Saras 3 is a telescope around this lake in Karnataka, maintained by Department of Science and Technology. Right? तो ये तीन चीजें अगर clear है तो more than enough है in this topic. Liquid mirror telescope last year news में था, दोबारा भी news में. So let me briefly tell you about liquid. Generally जो telescopes हैं, they have mirror. जो mirrors हैं, they have to be telescopes में बहुत large mirrors हम use करेंगे. These large mirrors will often be concave mirror, because the good thing with concave mirror is that they can converge light to a point at its focal point. But here is the problem. If your mirror is very large, then it will actually not converge at exactly the same point. It will converge, that is an optical problem, and it will converge at different points. So जो concave mirror है, that is not a very good setup for optical observation. So what scientists do is that they often make a parabolic mirror. The benefit of parabolic mirror is that even though it is very large, it will always allow light to converge at one particular point. Now concave large mirror बनाना खुद में देखो बहुत expensive है. इसको बनाना, repair करना, maintain करना बहुत expensive है, very costly. And parabolic mirror बनाना तो और भी ज़्यादा expensive है. So compared to these solid mirrors, some scientists, some cases we use what we call liquid mirror. So what we do in liquid mirror, let me explain with the help of a picture. So I don't have the picture of liquid mirror telescope. Liquid mirror telescope will look something like this. that there will be a parabolic container. In this parabolic container, you will have mercury filled into it. Now, mercury at its room temperature is liquid, and mercury is a very good reflector of light. But this, as of now, is not a telescope. What you will do after this is that you will have a mechanism which will allow this entire setup to rotate on its axis. If you rotate liquid on its axis, if I keep rotating it, the top layer of liquid head is going to take a shape like this. That shape becomes a parabolic shape. So if I rotate liquid on their axis, the top layer is going to take a shape like this. अब घर पे glass में आप rotate करके देख सकते हो. Clearly you will find this parabolic shape. So here you do not have to make anything. कुछ भी manufacture नहीं करना है. All you have to do is pour liquid into a container, into a parabolic container, and allow that liquid, allow this entire setup to rotate very slowly. And as it rotates, the top layer is going to take a parabolic shape. Now it will work like a parabolic mirror. This is very beneficial because you have reduced cost by 90-95% with the help of liquid mirror telescope. But there is a huge challenge, and that challenge is very simple because it can always and always look just vertical. Normal telescope क्या होगा कि if I am observing a particular galaxy, even if Earth is rotating, उस galaxy का orientation क्या होगा, थोड़ा बहुत change होगा. But I can move this telescope, no problem. But if I move this liquid telescope, जो पूरा parabolic shape है, that is going to be distorted. So it always has to look just whatever is in the sky at this point of time. It will be able to collect data about it. It will be able to give you good pictures about it, but not anything else. But the good thing is that with very less cost, you can basically calculate, or you can collect data about a lot of things, perhaps about space debris, your satellites, distant stars, distant galaxies. So one telescope which can be used for many number of things, and despite this, the cost is going to be very, very less. So it is a cost effective solution for astronomical observation. Now this actually became the first liquid mirror telescope into Asian region. So why this topic is in news? Because Asia's largest liquid mirror telescope that was commissioned at Devasthal in Uttarakhand, maintained by Aryabhat Research Institute of Observational Sciences, and we have collaborated here with Belgium and Canada. So the focus, the main objective of this liquid mirror is rotate telescope, rotate this mercury. It takes a parabolic shape, automatically behaves like a telescope. Space bricks was in news. With the help of Martian soil, scientists have been able to make brick, very similar to the earlier news that with the help of lunar soil we have grown plant. So ये जो brick है, this is also very important because if you carry certain constituents, certain components with you on Mars, I'm talking about manned mission, and if you have to make a setup, an infrastructure, a house, a temporary house, then you can do that with the help of such type of bricks. So I don't think this is important as such for prelims or mains examination, but nonetheless, out of interest, if you want, you can know about it. Yes. There have been many sample collection missions. There have been many sample collection missions from Mars also. Sorry? कहाँ पे? Tiangong is under construction space station by China. So in one line, just know that China as of now, China जो है international space station जो है, India is not a member, China is also not a member. As of now, the International Space Station is a collaboration among 5 agencies. So NASA, US basically, US, Russia, Canada, Japan and Europe. So these are the 5 agencies which are member of International Space Station. India is not a member, China is also not a member. And as of now, China is constructing its own space station called Tiangong. The goal of space station is that it provides a permanent platform for astronomers to go, stay there, conduct experiments. Many astronomers have actually stayed for more than a year on such space station, and there are hundreds of experiments which are going on International Space Station. So Tiangong, in one line, if I have to remember just one thing, that it is a under construction space station of China. So if I have to briefly tell you the topics in space technology, sorry, because it doesn't make sense to start a new topic, time hai nahi hamare paas, but if I have to briefly tell you the significance of topic, Mars orbiter mission not so important, but nonetheless few payloads, the fact that ISRO became the first agency to do something like this, in its very first attempt it became successful, ये सारी चीज़ें पता होनी चाहिए. And especially जो दो missions है, Perseverance rover and Ingenuity helicopter, you should know, because Ingenuity helicopter especially, it made a record that it made a flight on Martian surface. More than PSLV, if I have to remember, I will remember about SSLV and LVM3. So ये जो दो है ज़्यादा important है, because LVM3 made a record of carrying 6,000 kg into an orbit of about 1100-1200 kilometer, and SSLV because it is the lightest rocket designed by ISRO, a cost-effective solution to place Earth observation satellites into lower Earth orbit. Navik is a हमेशा important है. It is a India का खुद का अपना navigational satellite program है. The full form of Navik is navigation of Indian constellation. So India का खुद का program है, हमेशा ही evergreen topic है. Artemis is a very important topic because of what it aims to achieve. Few things about Artemis: this Orion spacecraft, distant retrograde orbit, the concept of skip entry, ये सारी चीज़ें बस एक एक लाइन में पता होना चाहिए. Along with this fact that जो Artemis 1 है, that was a unmanned mission, but NASA is actually planning that in future an manned mission around moon, come back, another manned mission on the surface. So Artemis 2 will have a manned mission, but it will go from Earth, will revolve around moon, will come back, and Artemis 3 will be a manned mission on the surface of the moon. And you should also know about this concept of Artemis Accords, which I told you, that as of now US has this set of principles. It is asking all the countries that you should sign this accord. This accord mainly entails that what type of objectives or what type of principles we are going to follow for space exploration, especially exploration of moon or other planet. As of now, India has not signed the accord, तो ये भी पता होना चाहिए आपको. Webb telescope would be important topic. In general, it is, I think, going to be important, but because there was a question in mains examination just last year, so I do not think कि prelims में भी UPSC पूछेगी, but अगर फिर भी पूछे तो few things you should know about it, where it is, its objectives, the fact that it is observing universe into infrared light, ये सारी चीज़ें कुछ पता होनी चाहिए हमको. In private sector participation, know about InSpace, what type of body it is, what are its objectives. Know about New Space India Limited also. What is New Space India Limited? Sorry? So sorry, I have to only public undertaking into space sector. ये देखना, ये only word है, उससे मुझे थोड़ा problem है. तो ये अगर ये देखना पड़ेगा. I have to confirm. Sorry, I couldn't. So ये जाके NSIL की website पे confirm करना पड़ेगा, because if only word is mentioned on their website, only then I'm going to accept it, right? विकीपीडिया पे मैं नहीं करूँगा. मैं विकीपीडिया आई एम नॉट गोइंग टू कंसिडर. कहाँ पे? नहीं, विकीपीडिया पे मैं PSU, विकीपीडिया पे जो भी है आई एम नॉट गोइंग टू यूज़ इट. आई एम गोइंग टू यूज़ इट ऑन जो भी ऑथेंटिक जो वेबसाइट, जो खुद की वेबसाइट पे. ठीक है. प्रोजेक्ट नेत्र you should know. The term Kessler syndrome you should know. What does it mean? In general, you should know about space debris and challenges they can cause. स्पेस टूरिज्म आई एम नॉट वेरी श्योर, बट कार्मल लाइन का जो कॉन्सेप्ट है वो पता होना चाहिए. Event Horizon Telescope Project, Sagittarius A, which is supermassive black hole at the center of Milky Way. What is this Event Horizon Telescope Project? What did it achieve? Not the first image. Another image was released in 2019. Such type of things you should know. The fact that it is not one telescope but many telescopes strategically located all around the planet. The fact that it is not an initiative of one agency, but this in itself is an independent organization known as Event Horizon Telescope Project. बाकी जो ये चीज़ें हैं लाइक टाइडल डिसरप्शन इवेंट, व्हाट एग्जैक्टली डज इट? इन वन लाइन वी आर टॉकिंग अबाउट ब्लैक होल फीडिंग अपॉन अ स्टार. In dark matter, what exactly it is, why this concept of dark matter, and some of the detectors. For example, this detector was very much in news, so I should know about it and where it is located. And you should also know in one line the significance of this concept of dark energy, that what is the meaning of dark energy. By the way, gravitational waves is also an important topic. UPSC has at least asked twice question from this topic, and they can ask again also. So few things you should know. It is a consequence of Einstein's general theory of relativity, a disruption into space-time, into a waveform which travels with speed of light, and the fact that there is a very famous detector called LIGO, which detected it in 2015, and a sister organization of that setup is also under construction in Maharashtra, India. ये भी पता होना चाहिए. अर्थ का टाइम रोटेशन चेंज हो सकता है बिकॉज ऑफ फिनोमेना, बिकॉज ऑफ मास डिस्ट्रीब्यूशन. इफ इट चेंजेस ऑन अर्थ, नॉट एनी चेंज विच इज हैपनिंग ऑन अर्थ, it can actually cause fasting or slowing down of Earth's rotation. This term Chandler wobble, what it means in just one line, you have to know that what is the meaning of this term Chandler wobble. DART mission, important for prelims examination, its objective, what it tried to do, along with this fact that this asteroid was actually never coming towards Earth. ये भी पता होना चाहिए. Sophia mission, I don't think that to be very important. Hybrid propulsion system, in one line just know that we are talking about liquid fuel, solid fuel, liquid oxidizer. HS-200, a booster for Gaganyaan, LVM-3 basically. Inflatable aerodynamic decelerator, you should know its objective and why this is important, because it has been developed by ISRO. बाकी जो आदित्य mission है, that is also an important topic because it was in news this year. So some of the topics: geomagnetic storm, coronal hole, sunspots, UPSC ने last year पूछ लिया है, so I do not expect a question. But बाकी सारी जो चीज़ें हैं, just an basic awareness that the terms and what they are, I think is more than enough for prelims examination. The next class we will start our next topic of, which is basically information and communication technology.